Mic check, mic check, mic check.
For live stream. You don't need it. No, the live stream. It sounds better over the mic. Yeah, so this is our 49th event, which what it means is we are completing our 11th year because we do 4 events a year, quarterly one. Good thing or bad thing, we were consistent and we didn't miss a single one. So our community has roughly around 4,000 members now. So, I think it's a proud moment for all of us. So thanks everyone for helping this community and keeping this alive for so long. Usually meetups come and go, but we sustained. And we'll be doing our 50th event in March. Obviously, that will be at Yahoo. That's more or less the place we started. So without further ado, I think, Batri, you would be going the keynote for LinkedIn. Super, I will invite Batri. So we'll miss the introduction time because my fault, accept it. We'll do that during the lunch and then the later open hours. So I'll invite Batri for the keynote from LinkedIn. Batri, go ahead.
Hey all, thank you for coming on a Saturday. This means a lot to the group. This is one of the key reasons why the LSPE event is successful for 49th time. I've been in several other I'm also running several other meetup groups, but getting a consistent audience and consistent talks is always a challenge. And LSPE group is doing it pretty much very good on that part. In fact, we have other side of a problem. We get a lot of proposals, and we have to go through which of the proposals are good and what we need to host it as a theme and then do it. So we are blessed, and thanks a lot for all of the audience who make it as a success. So I'm going to do an introduction. Hey, I'm Badrinath Ravindran. I am part of Edge and Traffic SRE at LinkedIn. My team, manages the steering, caching, and traffic layer for LinkedIn. So pretty much when you type www.linkedin.com, so how the traffic from the member, to the data center taken care by my team at LinkedIn. So that's it. LinkedIn has reached a month back, 1 billion member across the globe. That's a huge milestone for LinkedIn in the past 20 years. In the peak, in general, we serve about 2 to 3 million queries per second. So that's a kind of traffic what we get. Our member engagement is year on year is increasing by 10%. We in a year, if you put together, we will be maybe 20,000 billion requests kind of a thing. So that's the scale what from the user to data center. That's kind of a request we go through. To run these systems to this scale, we have to go through a lot of complexity, scalability, capacity, operability, observability, availability, incident management, and reliability. These are some of the aspects we have to traverse through to run a large scale production environment. So LSP Meetup is pretty much aligned to that. It talks about all these complexities, and people come and share their experiences and exposures or what they get it across. So this is one of the area where you can see what others are doing, what kind of learnings they had, what kind of challenges and how they solved it, and what was their approach. The other big benefit of doing is you get an opportunity to network to different people in the same domain. Again, this is not only SREs, only devs, only system. So it's kind of a spread of different profiles, and we have a lot of repeated audience. So that's the thing. One thing Devanshu mentioned, we missed the introduction. He knows a lot of people who have been regular comers and who are loyal to that. Thanks a lot, Devanshu, to drive this, and the core committee, whichever takes care of each of the hosting. As I mentioned, LinkedIn is generating tons and loads of data every second to serve their members. The member data is posted by them, or we generate, and also we search on them. There's a lot of things that gets enriched during the data that is getting generated or ingested into the system. So the first talk is like now going to be from Bhupendra Singh. He is a senior staff engineer. He is part of the data ingestion team. He is going to walk us through the data ingestion pipeline and what is the complexity of the platform, and he'll take you to that flow. So I'd like Bhupendra to come to the stage and take that.
Hello. Hello. Yeah, can you hear me? Oh, great. Yeah. So hey folks, I'm Bhupendra and I'm part of the data infra organization within LinkedIn. And data infra organization primarily takes care of providing all sort of platforms, the services, the tooling, everything you want to do with the data. So that's the data infra org is responsible for. And if you, so I think as Badri was already talking, like we are already 1 billion plus LinkedIn members, and every day any activity which is happening on the linkedin.com or LinkedIn app, it is generating massive data, right? And if we look at the different use cases, which we'll talk about it, so every system needs a data with a different set of guarantees, with the different set of quality, and for various other use cases, right? So though we will focus mainly on the offline part of it, but yeah, we'll look at the, let me switch the agenda slide. Yep. So here's the quick agenda for today's talk. So as I was talking, right, so we'll look at the overall LinkedIn data ecosystem, right? So right from the linkedin.com, if a member is doing some change, how the data is flowing across the various stores, how it is getting streamed, and finally how it is getting landed in the offline world, and then how it is traversing back to the online store to serve the site. So we'll touch upon that. We'll see the scale at which we are currently operating. We'll touch upon the use cases with respect to the offline world. We'll talk about the batch streaming and CDC ingestion, and of course the data management and our future plan of it. Yeah. So let's start. Okay. So I'm not sure if you have already seen this slide, because I mean this slide is present in many of the LinkedIn talks, but then this is a very simple representation of the overall data ecosystem and how the data is traveling across various systems, right? So, so if you look at the data generation part, so as I mentioned, I hope everyone has the LinkedIn account, and so we all are LinkedIn member, and that's the terminology we used within LinkedIn. So LinkedIn member, right? So let's say you are just going through navigating across various pages in LinkedIn. So that is like your page view history, like your page view. We are tracking like which pages you are viewing. If you have done some clicks, that's like generating a click data sort of a thing. If you will go to your profile, change some settings, that's like kind of a another change which you are generating. You may post something, you will do likes. So these are all source of data which will be generated by the member doing any activity on the site. Now, what happens is first, all this data will be captured by our online services, and it will reside in our source of truth data sets in the online store. So we have the Espresso as an document store, which captures all the member settings and the related data. We have the MySQL, Oracle, which again captures a lot of the source of truth data sets. And then if let's say you are just navigating across pages, right? So it means you haven't changed any of your profile, or you haven't done any change. You are just navigating across pages, right? So those kind of a data will be captured by services, and it will be emitted as an event. So like this activity has happened, and then it's up to the underlying, I mean downstream use cases, how they want to consume this event and process. Yeah. So for an so what will happen is, let's say you are let's say you have done one change in the your settings profile, right? So that's like that will generate a CDC event. Okay, let's say I'll change my email ID from some A to B. So that is like a change which is like you have done one update on your member settings. So that's like a CDC event. Other type of event is, okay, why I'm explaining all this, because this is the context I will be using in the further slides. So this particular change I'm referring as in a CDC event, and the other change is like just activity log. So that's a plain raw event, and that's not related to CDC. Yeah. Now all both of these events will be captured by the nearline streaming pipelines. And then there are use cases wherein some processing has to happen in near real time. Let's say you are building your search indexes or some sort of a fraud detection activity. All these things, all those systems will consume the data from this nearline streaming pipelines. And then same streaming pipeline will be consumed by the offline ingestion pipelines, right? So we have the offline ETL, which we'll talk about in the next slides. So the CDC stream and the activity log stream both will be consumed by the offline ETL system, and it will dump into the raw data lake. Now what will happen is after the data has arrived in the your data lake, there are various use cases as we all know, right? The AI, ML, they will do the modeling, they will do the derived data set, they will derive meaningful insights out of this data. And then again, this data has to travel back to the member. Like let's say if we are doing some jobs recommendation, so that job recommendation data will be again going back to the online store, which will serve the member, in the app or the site, right? So depending on the use cases, our online store, which is again serving this kind of a thing, is of course the Espresso. We have the Pino for as an OLAP sort of a system. We have the graph databases, which will serve the LinkedIn economic graph. We have the search. So these are all the system, which will get the data from various services, from the offline, from the nearline, and even from the online. And then all this data will be served back to the member. Yeah. So this is like a very simple representation of how the data is flowing across various systems. Now we talked about LinkedIn member. LinkedIn also has a concept of, the customers in the sense LinkedIn has the LinkedIn recruiting platform, the LinkedIn talent solutions. So those are all the LinkedIn customers, and they are, whenever they are doing any activity, it's the same flow. The data is generated and it's kept, it's like it travels in the same life cycle. Let me move to the next slide. And of course, so the third source of data generation is within the LinkedIn. So as and when you are processing or reading all these data sets, and again you are writing to your own store, that means there is a data getting generated which has to be ingested and which has to travel within all the system. So that's like a third source where LinkedIn will get the data. Okay, let's look at the scale. This slide is a bit stale. It's already 1 billion members. And then specifically talking about the offline data lake, it's already at exabyte scale and increasing every day. And then if we look at we talked about the CDC event and the activity events, right? So we have the trillions of messages in motion per day. So that's the trillion of messages at any point of time getting processed by various systems. And then in the offline world, we use the Hadoop currently, and it's already we have 10 plus cluster, of course, federated across various data centers. And then for the offline, if we see, we are actually ingesting more than 10,000 event every day, and which generates the several petabytes of the data. So that's the current scale, and these numbers are increasing as we are talking. So, okay, so let's look at the so let's look at some of the use cases actually. So whenever we talk about the data ingestion, we need to be mindful of having the right data at right time and right place. Three things, right? So having the right data, I'm attributing it to the data quality. So if you don't have the right data, of course, you're not gonna whatever processing you are doing, it's gonna be it will be result in failures. So having the right data at right time. Right time, I meaning, so though we have the offline data lake, but the use cases which needs the data immediately in the real time or near real time, they cannot wait for latency of several hours or a day. That is not acceptable. So having the right data at right place and the right time. I mean, so if I need the data in the online store, it has to be in the online store. If I need a batch sort of processing, I want to process like last 2-3 years worth of data, I need to go to the offline data lake. So having the right data at right time and right place is the key. That's what we try to match. And to give the examples, I think I already talked about the abuse prevention that happens in the near real time. So any activity which has happened, and when the it travels through our streaming pipelines, the abuse application, I mean abuse prevention application, will just detect it, and such post will be turned down within few minutes or hours. But then if you talk about the jobs you may be interested in, people you may know, those are like the offline, they consume the data from offline data lake, and that requires a lot more data for their training purpose and various other purpose, right? So these are like PYMKs, like people you may know, again the connection recommendation and all. Economic graph is the graph indexes, and it will represent, I mean, so it will store all the data in the graph database, and it will represent the economic state of the entire world. I mean, that's how it is calculating. So yeah, and I think various source of data we already talked. So data, member activity, and even within the services we are doing the because we have the different data centers at different locations. So even for the disaster recovery purpose, the data is getting copied from one data center to another data center. So why I'm talking about all this, because these are all source of data which has to be ingested by the offline data ingestion pipeline. So though the member activity is one source, but these are the various other sources which are putting the scale requirements on the offline ETL pipelines, right? Okay, I can skip this slide. Let's directly go to the let's talk about the system, right? So we talked about member doing activity, online services, putting the data in online source of truth databases, generating the events. Those things are getting emitted as an event, and then it is traveling to the nearline streaming pipelines, and now that is the source of truth for all the ETL ingestion, right? So Brooklyn is one such system which we are using today. So as we talked, like I am going and changing my profile information, right? So how what will happen? So let's say something is changed from A to B, it will go and sit in the Espresso we use. So it will go and change one particular record in the Espresso document store, and that Espresso will underlying have a change log. So what the Brooklyn system will do is, actually it will in the near real time, it will go and tail the logs, and every change will be emitted as an change event. So the Brooklyn is essentially okay. So Brooklyn is actually, if you see the architecture, the source is very flexible. You can plug in any source, and then of course any destination. But then within the LinkedIn, the sources are for the CDC. It's like a MySQL, Oracle, and now TiDB and the Espresso, which captures all this data. And then the second part, as I was talking about, like we have various data centers, and the member activity or this particular change is happening across various data centers, right? So for a pipeline to consume the data, one way is like it can go and consume the data from every data center, put a hook and consume it. Or Brooklyn is the system, what it is doing is similar to Kafka Mirror Maker. Brooklyn has a Brooklyn Mirror Maker. It will aggregate the events from all the different data centers, and it will provide a unified stream. So when I say unified, when we talk about, let's say, CDC, though we have the MySQL, Oracle, Espresso as in a different system, but then finally for the consumers, it's one single format where you get your CDC stream record. So Brooklyn, these are the two primarily use cases. One is telling the logs of the online databases and producing the CDC stream in a unified way. And other one is the Brooklyn Mirror Maker, which is mirror the events from the different data centers, aggregate and provide me one unified stream, so that as a consumer, I need not worry about the various data centers and how many data centers are there underneath, how we are expanding and all. So Brooklyn abstracted all this. So now this is the input. Whatever stream Brooklyn is generating, that is the input for the offline ingestion. So let's talk about the offline ingestion, right? So offline ingestion, we have the batch ingestion and of course the streaming ingestion, and we currently using the Apache Goblin. And Apache Goblin, if you look at the constructs provided by Apache Goblin, so it has the source and it has the finally data publish. So okay, so source is okay. Again, this architecture is generic enough. You can plug in any source and any publisher, and in between we'll talk about the various other construct. But then if you stick to our use cases, so here the source will be the Kafka source. The Brooklyn has produced one stream, the change stream, both a CDC stream or the activity log stream, both are Kafka. So this is a Kafka source. And now here source will run in the driver, and source will decide how to distribute this particular processing. So what will happen is, let's say you have a Kafka topic with 100 partition. You may want to, I mean, just for simplicity, you want to have 100 containers processing every partition and dumping into the HDFS in the data lake. Yeah. So the source will do this planning, how the processing has to happen. It can even decide, okay, I just want to do it in 10 containers, and it can bin pack multiple partitions into one container. So in Goblin world, it is referred, this planning is referred as a work unit, and every work unit is processed as a task in a container. So that can be any container, but today it is for batch. Goblin has a mode of map reduce, and this is actually running in a mapper container. We'll talk about the other containers. What will happen now? So once I got the container, I have the work unit, and then this is a batch jobs. It is a bounded stream. I am saying for this particular Kafka, process from offset, start offset and end offset. So it's a bounded stream. Now every task, when it is processing, it will of course extract is like it will go read that particular partition. If you have to do any transformation in between, you need to do, like, even if you need to evolve the schema, or if you need to do some data type conversion or whatever. So any sort of a transformation you want to do, the convert is the pluggable interface, which will you can plug in your stuff there. And the quality interface, right? So quality interface is play a critical role. So when you're ingesting the data, of course, you don't want to corrupt your data lake, and you don't want to produce the unhealthy data, because the consumers will fail, or it will result in the wrong output. So the quality checker, what we do is we do some basic sanity check, whether the data is as per the schema defined, and whether whatever bounds, whatever rules are defined, are those all those rules are satisfied or not. So this happens in the quality phase. And then finally, I mean, of course, the writer, so which will write in the data lake. Currently we use ORC as our columnar format. And then data published. So finally, when I have all the containers have processed the data, and let's say in terms of the Hive, I have the one let's say hourly partition ready. I need to go and register into Hive table, so that the consumers now will look at the new partition and they are ready to consume. So the data publisher job is to make catalog aware the new data has been published. So this is the batch model we have now, but this is not sufficient, because the batch the latency is several hours, or in sometimes a day, and then the use cases requirement is like, get me the data as fast as possible, right? So the same Goblin constructs are changed to run in a streaming mode. So earlier it was like a map reduce, and we are getting a mapper bounded stream. Now it is changed to a custom YARN application. YARN AIM will request the number of containers which the streaming application will specify. And then now the same construct will run as an unbounded stream. So every container, we are saying you process this particular partition and keep processing it, and then do the checkpoint every 5 minutes. So it's like if they are doing buffering or whatever in memory buffer they are keeping, so they need to flush in the 5-minute time interval. And the same publisher which is registering the doing the registration in Hive. Okay, so here is the thing. So this particular streaming job is divided into 2 jobs. So one, I mean, data and metadata is decoupled. So the streaming job responsibility is only dump the data and do the checkpointing every 5 minutes. And the metadata streaming job is responsible for whatever is dumped, and that is emitted as an event. Whatever is dumped, consume it and register it to the underlying catalog. It can be Hive, it can be Iceberg, so that the consumers will see the data immediately. Why we have decoupled? Because you assume there are like thousands of containers running, and every container, if start publishing, there will be millions of snapshots in the Iceberg world, which is not scalable. Or if you are doing those many operations with the Hive will die. I mean, that's the reality. So the metadata streaming job will do some micro batching, consume the output of all these containers, and do the one-time registration. So now within LinkedIn, we are referring this as a fast ingest solution, and we are able to achieve the latency of less than 5 minutes. Currently, we are migrating to the Apache Iceberg format. During this migration, we are doing the dual registration. Same data sits in Hive, and it's also published as a Iceberg table. So the consumers, the legacy consumers on Hive will still see the same data, but the new consumers on Iceberg will be able to consume the data as well. So it's a dual publish model, and ORC is the file format. So yeah, and of course, because the streaming job, we have to do the, based on the workload, some Kafka partitions may become hot. It may get the busty traffic. The Kafka topic may be repartitioned at the source. There might be new topics which you have to ingest. So we have the replanner job integrated with the streaming solution. So what it will do is it will check the load which is getting processed every few minutes, and then do the replanning. So replanning, what I mean is, like, if let's say one container is processing 10 partitions, but still it has a luxury of processing more, it will do the reassignment, and it will assign few more partitions, and vice versa. So that's the replanner module will be doing it. Yeah.
So the container is suddenly more partitions. There will be hotspotting in terms of CPU or maybe some resources, right?
Yeah.
How do you deal with that?
Yeah, good question. So okay, so the replanning happens in the driver side, AM side. So when you start the application, you already know you have 10,000 topics to process, and the assignment plan is made. Now the replanner module, which is running in the background, and it will give an instruction to the driver saying these topics are becoming hot, which needs to be reassigned, and this is the reassignment plan. So the existing, so it will give a signal to the existing container saying you need to cool down, I mean turn down, and then the new assignment will happen. So it means you checkpoint your state, and then that particular partition will be reassigned to some other container.
That's data movement. That is what latency again, right?
That's not a data movement, because this particular job is just reading from the Kafka and dumping into the data lake. So data is already present in data lake with the state, what it is already processed. So state, I mean, it will record till which offset I have processed. So that means if this, I mean, the container can go down anytime, right? So whenever the new container is starting the task, it will resume from that particular offset. That's the idea.
It's not localized for the container.
Data is not localized for the container. Data resides in the HDFS today. Yeah.
Do you maintain any audit as is for audit purposes?
What sort of an audit you are talking about?
Just for
Okay, I'll talk about that. We have a slide to touch upon that. So yeah, but we do have audit data available. Yeah, certainly not for every record, the audit is not possible, but then we do have a checkpoint, and there is a separate compliance job which takes care of complying to all the rules. So all the data which you are dumping is again read by many compliance jobs to make it compliant as per the GDPR, CCP, and various regulatory requirements. We'll talk about this.
Since the data is not localized for the container,
Yeah.
there will be huge disk IO reads happening and a huge battery consumed, right?
I mean the huge or not, that we need to quantify, but then because of the reliability, you don't want to lose the data. So it has to be in the reliable store. Then HDFS is the current store which we are using. Yep. And HDFS underlying will do the 3 replica, and that's the model.
Yeah, how do you address gap
Okay. Yeah. So the cap actually it will suit best for the online world, where we have the Espresso and MySQL and Oracle, which is serving the site and source of truth. For offline, it is like an eventual consistent from the online world. So we don't. Yeah, we'll talk about this. Like CDC example will touch upon those aspects. So there are like pros and cons, and for some use cases we have to worry about it. Let's walk through the some examples later. Yep. Okay.
So you mentioned that the latency is less than 5 minutes.
Yeah.
How complex are the transformations involved? Are there windowing and stream joins present?
No. It's a straightforward transformation as of now. It's just a schema evaluation, as I know, and converting from Avro schema to ORC. Not doing any heavy join. We do have a joins in other pipelines, which is based on the Goblin, like the compliance and all, which but then not in the ingestion. Okay, so the Goblin world, which we talked about, is like the activity log, the Kafka string, just dumping it. But CDC is a bit more complex use case, in the sense, if you talk about the HDFS is immutable store. So once you have written your ORC files, you can't go. I mean, if you have to change it, it means you need to do the rewrite. So if any one row is updated or deleted, and if you want to reflect it immediately with the strong consistency, what we are talking about, then it's like you need to rewrite, right? But then it's already like a petabyte of data. Every change, you can't afford to do the rewrite. And I think the models which is already famous is like copy on write model or merge on read model. So copy on write is like every time any change which is happening, you batch it and then you rewrite your entire snapshot. So of course it will be heavy IO activity, and depending on the use case you need to adopt. And second popular model is merge on read. So you have a file, you will record all the deletes or update in a separate file, which is like a delta file. And when you are when the consumers are reading the your table, during the read you will be merging both the files, merging in the sense in the memory when you are reading. So and then you will decide whether the record is deleted or whether it's updated to reflect the latest version, right? So now the Opal is slightly different. What we do here is it's a read time filtering. So whenever we ingest the CDC data, we compute the metadata of every record, reflecting whether it's update or delete. And during read, instead of merge on read, we are doing read time filtering. So I will read one ORC, one record, and then using my metadata, I will get to know whether this record is visible or not visible. When I say visible, that means this is a latest copy. And if it is not the latest copy, it in the metadata will say it is not visible for this particular timestamp. What do I mean by timestamp? Users are allowed to do the time travel. I can go back to 1 day old snapshot where this particular record is visible. So what Opal will do is it will actually, it's a batch job today. So every hour, whenever it is producing a new snapshot, it will have the new metadata associated with it. And then based on the time travel window for, let's say, 7 days, 30 days, whatever is the time travel window, it will keep those metadata, and users can go back to any historical time. So this is one difference with the Opal. And then, yeah, what else? Yeah, so this Opal solution is basically for the CDC the Brooklyn system, which is producing the CDC stream, which is consumed by the Opal pipeline. Underlying platform is Goblin and set of Spark jobs to compute the metadata. Now the question is like, if during read time filtering for every record, if I need to go to metadata and check whether it's visible, not visible, it's very expensive operation, right? So why not merge and read? So so here metadata is kind of we maintain a bit set. So with every record we have a logical ID created, and for that ID we have a bit set created wherein every bit saying whether it's visible or not. So now whenever the read is happening, this particular bit set is loaded in the memory, and of course it's a bit set, so it doesn't take a lot of memory. And then checking whether it's visible or not, it's a O of 1 operation. So it doesn't really evaluate any expression or need to do any other processing. So that's why it is really fast compared to other two currently in our use cases. Oh, gone. Okay. Okay, so third part of it, right? So these are first two systems are like managed by our team, and it's like a managed pipeline wherein every data, every CDC change has to be recorded. Now users will consume this data and they want to do the similar stuff by their own, right? So they want to have their ETL pipeline or do the data movement and all. So we have the data movement as a service. Underlying, I mean, Goblin as a service or data movement as a service. So as a user, you need not worry about the internal complexity of the Goblin platform or writing the lot of code. As a user, if your use case is like, let's say just for disaster recovery, you have your own tables and you want to copy it to another data center, or you want to copy it to some other location, you just want to say this is my source table, this is destination table, and just do it for me. Or you want to say, okay, my source is MySQL, or my source is some external HTTP source, and then you dump the data at this location. So I mean, for the user who are not really familiar with the offline world, the complexity of the system, the data movement as a service comes into play. And it's like it's a declarative data flow is what they mention. They can mention, okay, I want to move data from A to B, B to C, C to D. So this is the flow they will mention, and internally it will be converted to logical flow to DAG or physical spec, and that will be managed by the service. That means the complete data movement will be orchestrated by the data movement as a service. It will be set of multiple jobs will be involved here. But then this is the interface currently provided for all the other users who are not familiar, who doesn't want to deal with the complexity of the underlying system. So this is like a sort of a service which is provided currently used for disaster recovery heavily. So there are 100K jobs running on the daily basis, like copying data from one data center to another data center, and of course the data backup stuff, right? So it has a Hive DistCP. I mean, I'm saying Hive, but it's a table DistCP actually. So it does the binary copy of the files and do the registration as an Iceberg table or Hive table. So yeah, so these are the three main stuff, four main stuff. Brooklyn producing the stream, the Goblin batch pipelines are there, Goblin streaming pipelines are there, and then the CDC stream pipeline, CDC ingestion pipelines are there, which is the Opal. So these are the main pipeline. There are other, but these are the main pipeline which is getting data into the offline data lake. Yeah. Now, so far what we have done is we have just dumped the data. But then there are a lot of data management activity which has to happen, because every 5 minutes, if you are producing a file, you are creating a lot of small files, and then you are putting a pressure on the underlying storage system. So currently we are using HDFS, and if there are too many small files, it puts a pressure on the name node memory, and it puts an scalability requirement on name node. So there are compaction jobs which will be incremental compaction which is happening. So it will merge the small files into a larger file. I think many of the systems are doing that, so it's not a new stuff. But then yeah, second part of is we talked about the CDC and time travel. So the compaction jobs has to clean up the old data. Like I have done some updates, it has to be cleaned at some point of time. So after the time travel window is passed, those data or those tombstones will be deleted. So that's again taken care by compaction job itself. The data deduplication, again, it's combined with the compaction job. So it's like when you're consuming from Kafka, there are scenarios where application end up in producing duplicate records, or because of some errors, your pipelines are producing a duplicate record. So the data deduplication pipeline takes care of removing the duplicate record. So that's another pipeline. And of course, the data, you can't retain it for various reasons. So there are retention pipelines to take care of that. Compliance, GDPR, CCPA is one of those. And this pipelines are like running daily. These are all built on top of the Goblin today, and some are like a variant of Goblin. And what else? Yeah, so we talked about the data quality within when we are doing the ingestion, but that's not sufficient actually, because you can't afford to do all sort of a data quality check. So we do have the offline job to do the data quality check. So one scenario is like, let's say we talked about the CDC stream, and because of some failure in some system, one of the update has not arrived in the offline. So you periodically you need to reconcile your data. You need to first detect if there is any miss, and then you need to bootstrap your snapshot again. Like the Opal snapshot, I'm consuming every hour. But then if there are missing events, then either you need to rebootstrap and start doing it, right? So the data quality jobs takes care of flagging those kind of events, and then the remediation. Okay, so this is the new stuff. So as we talked, like historically we were on the Hive table, and the Hive catalog and the Hive structure of how we manage the data. And now if you would have heard of the Apache Iceberg. So Apache, we are moving to the Apache Iceberg format, and of course there are various reasons for that. Apache Iceberg provides the snapshot isolation, the read isolation, the time travel, and okay. So just to give you a simple example, Hive actually refers to the physical partition, and underlying, if you go and change one file, that's like if you let's say you have a job which is running, your job will fail. If you are reading that particular partition, your job will fail. But then in Iceberg, you are actually reading a particular snapshot, and any new change which is happening, it will produce a new snapshot. So readers are isolated from the write. So that's the one part of it. And then time travel means you can go back to any older snapshot. And then yeah, there are various other cool features of the Iceberg, and there are reasons to move towards that. And now, as I talked, like Opal, we want to move to Iceberg, and whatever good part of Opal we have described, we want to see if we can merge it to Iceberg, or Iceberg works well for our use case. So that's the work which is currently happening. Okay, so yeah, okay. So as the members, LinkedIn members are increasing day by day, it's like a lot of data, more data. So we always have the scalability challenges, and we are evaluating modernizing our tech, leveraging some more open source if it is really fits our use case. That means like I mean currently we are evaluating Fling streaming as an alternative, and we are experimenting whether it is good enough to provide same sort of a guarantees which we were providing earlier. I mean, of course, the one solution is like we keep investing in the existing Goblin and streaming infra, and enhance that to make it scalable, or leverage the open source. So both the options are there. This is work in progress. And yeah, unifying the table format to single table format. So maintenance part of it, or even I mean it's really difficult when it's like today we have 500k plus tables, and if it's a different format, different compaction, different retention, it's really hard to manage. So we are settling down on one table format. That's the direction we are taking. And yeah, of course, Open House, there is a blog published on Open House. That's the catalog we are planning to use. Sorry, yeah, that's it from my side. Thank you. Any questions you have?
Hello.
Yeah,
I'm here. My question is regarding client side when we are operating from mobile, right? So there would be the cases where we will be having a small payload or large payload kind of scenario during either creation or updation. For example, I'm posting a blog content. It will be the big chunk, right? So how do you handle this kind of scenarios?
You maintain, you post some
Small, yeah, it might be small,
picture.
small data
Okay.
or large data sets, right?
Okay.
So, do you segregate it, or you treat everything in a stream, or yeah, what are the different postures?
So let's say, yeah, okay, if I'm not sure if I get the question right, but let's say LinkedIn.com, LinkedIn app, you go and you put a large comment or you post a picture or something.
Yeah, picture or blog or anything, right? So there would
Yeah.
be the small, just I'm tweeting or commenting, it would be the small data, right?
Yeah.
If I'm posting a blog, that
Yeah.
could be the bigger data.
Right.
So there would be the scenario you will
Right.
be having a smaller payload or larger payload. How do
Yeah,
you take it?
Yeah, so good question. I think I didn't talk about the our blob store. We have the Ambry as in blob store to capture the large videos or pictures or those kind of a things. And if it is a large post or a comment, again it goes and sits in our document store. And I don't remember seeing some scalability issue when there is a large post which cannot be accommodated in the current document store. So the document store for all the large post, replies, comments, all those things, and for all the other media, we have the blob store which will persist it there, and then from there onwards it has to fly in the offline world. So in the offline world, the strategy is if it is a really big messages, yeah. So our plan is, our strategy is like those should be dumped as a separate file, and within your record, it should be just referencing to that particular file. It should not. That's the recommendation. Otherwise, it's like your one ORC column or Avro column, whatever format we want to use. That's like you are having a millions of bytes in one particular column, and that will though you are able to write the file and then one particular column is like a GBs of data, that may not fly well. So such large messages will be dumped to some other file and only the reference of that will be provided in your record, and whoever is the consumer, they will take care of reading it from the appropriate file. So those are mechanism. There will be more. I think we can catch offline if you have more questions. Yep. Yeah.
Yeah, so you mentioned about data deduplication in data management part, right? So two questions basically. Isn't the semantics at least once or at least at most once delivery semantics taken care during the streaming flow? And is deduplication handled across multiple files? You mentioned that every 5 minutes there is a file written. And do you take care of deduplication across files as well?
Yeah, I think good question. So this is how it happens, right? So for your first question, exactly when's guarantee? As I mentioned, there are the failures. There are various places where the failures are happening. So first of all, the application side itself, we don't have idempotent producers as such. So the application, if they don't see a signal back from the Kafka, they think it's the message is not gone and they will produce a new one, right? Similarly, in the ETL pipeline, though we are doing the checkpointing, it is after every, let's say, 1 minute, we are recording it. So during that time, it may happen we end up writing the same record again in a new ORC file. So, this is just two examples. Both of this will generate the duplicate data. And to guarantee there is no duplication, we need to do the dedupe. Your second question was?
Isn't deduplication across multiple files is a complex operation?
Yeah, so currently the deduplication we guarantee for the 24 hours window. So we don't go beyond 24 hours. So there, its guarantee is not 100%. Within 24 hours, it's like 99 point some nines. That is the guarantee. Yeah.
Hello.
Yeah.
So can you put some light on performance or benchmarking?
Sure. So I think I don't have the latest number, but these blogs are there which talks about the various performance benchmark and comparison. So I have listed all the blogs here. The Opal, the Goblin, the Fast Ingest, and the things. Yep.
Do you have any article on Replanner, how it works? Is there any...
Fast Ingest blog covers that. Yeah. Yep. And by the way, if you have any questions, you can reach out to me. This is my LinkedIn profile. Yeah. Yeah. Thank you.
Hey, thanks a lot, Bhuvendra.
Yeah.
That's pretty engaging session. Okay. So we ingested a lot of data. So we given the problem for them to scale up the database in AWS. I hope end of the session they'll also be able to give us some coupons for AWS purchase. Okay. So passing on to Niranjan and Sandeepan.
Okay. Thank you. Hello. Good afternoon, everyone. My name is Sandeepan, and I am a senior operations manager in AWS Premium Support in the Bangalore office. I manage the team of database, big data, and analytics. It's nice to be a part of this community and happy to see so huge number of technical geeks. So really excited to be a part of this. Thank you for coming. Yeah. So just to quickly give you the background, what we do in Amazon or AWS Premium Support. As I told that I manage the data profile, that is the big data, database, and analytics. So we know that data is everything for any company, right? It can be a small data, it can be a large data. Without data, we are nothing, correct? So whenever customers face any kind of problem like data is not proper or the performance is not adequate or there is a data corruption, right? So at that point of time, they open the support cases with us, and our support engineers are responsible for working or troubleshooting on the problem and fix the problems on behalf of the customers as soon as possible. So there are various levels of support, and the support engineers are technically proficient or technically expert in resolving the problem, right? So as you know that, as I told, right, the data is everything. So keeping the data up to date or keeping the version of the database up to date or on the latest status, it is very important for the health of the data, right? Any database companies, it can be Oracle, it can be Microsoft, it can be open source databases like MySQL or PostgreSQL. They release versions after versions, and with every version, they fix a lot of problems, a lot of bugs, which will always ensure that the data is proper. Right. So in this session, we are going to talk about multiple flavors of what are the best practices of database upgrade, how you can leverage the best out of the RDS, that is a relational database service, which is the platform given by the Amazon Web Service for handling the databases. Right. So having said that, let me hand the mic to Niranjan. So Niranjan, why can't you introduce yourself?
Thanks, Andy. So hello, everyone. So good afternoon. So I'm a senior support DBA at Amazon. So I'm an expert in RDS MySQL and Aurora MySQL. And as a senior support engineer, I'm the highest level, one of the highest level of escalations within the support engineering org. So like Sandy mentioned, so whenever customers come up with issues with respect to database, they reach out to us. And when it's too complex and which cannot be handled properly by the lower level of support, it reaches out to me. And then it can be like looking at the code, it can be looking at all the layers of the databases to understand what exactly the problem is. If I have to just speak about one such example, you know that MySQL and InnoDB kind of like provides you a lot of internal views, which can be like just queried upon to get information about the metadata. So just running a select on those internal views can cause a lot of CPU utilization, resource throttling, and performance issues. And this was because of a bug in the code in MySQL. And something like this might not be possible for a normal support engineer to like troubleshoot this, and it reaches out to us. And then I looked at the code and I kind of like troubleshoot, okay, this particular piece of code is what is responsible for the throttling of resources. So that's one of the examples like how we work on escalations. Yes. Yep. And as Sandy mentioned, on completion of this particular session, you know how to tune the database to serve at scale, and then what to expect when you perform a DB version upgrade, how to avoid surprises after DB engine version update. And then yes, to avoid surprises, you need to test. So I'll probably like share few best practices that you can follow and how exactly you can test to ensure that the newer version that you're going to move to, it's going to be like proper. Yes, tuning the infrastructure to serve at scale. I hope it's audible, right? Is the mic close enough? Okay.
It's a little bit closer to you.
Sure.
Or
Okay.
we give them another pocket.
No, no.
The color.
That's okay.
That's okay, Sandy.
Okay.
Cool. Yes. Okay. So tuning the infra at scale, first thing to know is about the resource utilization of any system. So you might be aware of whatever you are seeing on screen: CPU, memory, storage performance, and network throughput, right? So one simple thing that any user who's gonna like come start using RDS will have to like look at these things. So in order to get the best performance and to ensure the best service from RDS, you need to ensure none of these are throttling. So what is CPU utilization? You should know the utilization of the cores. So you should ensure that CPU isn't throttling. You should ensure that the memory doesn't go low. You should ensure that the storage throughput is not throttling. Again, what does RDS like guarantee you? We give an SLA of 10 millisecond latency. So you should just ensure that whenever you're using RDS, the latency shouldn't go beyond 10 milliseconds. Again, I'm speaking about the storage latency. The query latency overall might vary. So storage latency shouldn't go beyond 10 milliseconds. And just an example. So again, similar to that, we have network performance. So none of these things should be throttling. Okay, when does network performance come into picture? You have replication, you have huge payload being sent to the database, or huge payload getting received from the server to the client. You need to like keep an eye on the network performance. So yep, you need to look at these things. But how are we going to look at these stuff? So again, you're going to like first benchmark. So benchmark it with probably the benchmarking tools, or again, you might be using database, or we all might be using databases in on-premise machine or a different server. So we know what is the CPU requirement, memory requirement, storage requirement, and the network requirement. Use that as the baseline and start with RDS. And yes, you can like scale up and down. RDS provides that feature of scaling up and down your resources to make sure that you have the enough resources. And yes, we have serverless feature in Aurora. So what does that mean? You don't provision the compute capacity or the memory capacity or the network capacity for the instance. It's serverless. It's going to scale based on what you use and what you need. So that can be used in two cases. One, if you really want to like have a system which is going to scale and up and down based on your spiky workload, go with Aurora serverless. Else, again, to benchmark, start with serverless, understand what is the CPU and memory utilization that's happening with your workload. Use that and now move to provisioned so that you can fix the configuration that is needed. Yes. Now, how do I ensure that I'm not hitting these limits? How do I ensure that I'm not probably like throttling? I'm not running slow. Again, we have several monitoring in place for RDS, starting with CloudWatch. Okay, CloudWatch, it's just going to be the OS level metrics with RDS. So it's going to give you probably what is CPU utilization, what is the freeable memory, and one probably the disadvantage that I would say is it has a granularity of just 60 seconds. So you have a spiky workload, CPU spiking for just few seconds, it's going to smoothen the graph for you. So the CloudWatch will just show it as a 60-second granular metric, but then it's good to start with. And this is going to come in whenever you're going to launch the RDS instance, and this is a mandatory monitoring that is going to come with your service. But yes, the additional two monitoring that you have, enhanced monitoring and performance insights, they are like the optional ones. What does enhanced monitoring give you? It's again the OS level metrics. It's more like a graphical representation of top command on Linux. So It's gonna like give you the breakdown of CPU. Again, when I told about CloudWatch, you probably might be getting only as CPU utilization or only freeable memory. But when it comes to enhanced monitoring, you get what is the total CPU, what is the CPU consumed by MySQL or any other database engine, or what is consumed by the RDS internal processes, and so on. And again, enhanced monitoring has the flexibility of granularity as well. You can start with 60 seconds, you can go up to 1 second granularity to ensure that you're capturing the spiky workload. Performance insights, I would say it's a combination of enhanced monitoring plus engine level metrics. Again, for those who have used MySQL, you're aware that performance schema is a very powerful tool in MySQL, which help you understand what is happening at the MySQL layer. So performance insights is a graphical representation of the performance schema. So you get a clear visualization of enhanced monitoring, that is your resource utilization, along with what is happening at the database layer. So you get to correlate both of them and understand, okay, this is the load on my database, and it's because of this query, and it's because of the stage within this particular query. And yes, probably it's using buffers, cache, etc. Everything would be given as a breakdown. Yes, please.
Normally, you said in enhanced monitoring, you can do as low as 1 second, 1 second clicks. Normally in Linux, I not use AWS much.
Sure.
If you start top and if you do the D2 one, the top itself will start consuming a lot of CPU.
Yes.
Over here, if I use enhanced monitoring of 1 second of granularity, would it not affect the performance of the RDS?
Okay. To be honest, we don't directly run top. I told it as top just to like probably like make it simple, but then we do something at the backend to capture the information for you. It's a very lightweight process that we do at the RDS layer. So yes, if you're going to benchmark, you'll see that enhanced monitoring is going to consume some amount of resources. Probably if you're going to go with a very small instance which has 1 or 2 CPU cores, but then yes, going forward, like for a bigger instance class, you'll not even see the difference. It's very lightweight.
So if I'm going to benchmark, I should always make sure that there is 1 or 2 cores separately reserved for.
Yes, to be honest, yes. If at all you're going with a very small instance, will not recommend even enabling enhanced monitoring and performance insights, as it might just use up your resources. Yes. So along with these metrics, you get to also add alarms to these metrics. So now you know how to like what to look at from these metrics, but then yes, you need to take decisions proactively. You can't wait for an event to happen. So yes, you set up CloudWatch alarms. Okay, CloudWatch is a service in AWS again, and you use alarms on all these metrics: CloudWatch metrics, enhanced monitoring, and performance insights. You set alarm again. We need to find the threshold that works. So you can't set a threshold as 100%. That's of no use. You need to probably like start with 80 or maybe 70. Again, based on how sensitive your application is and how fast your workload can probably like utilize resources. Start with that. And then yes, once you get a notification, scale up and down so that you move to a higher or lower instance class. Yep.
So to answer the question which you asked, right, as Niranjan mentioned that if it is a production instance, we know generally the CPU or the memory is kind of high. Means you basically keep 16 core CPU, right? Or maybe the memory is like 100 gigabytes, right? So if that is the case, and enhanced monitoring, it is kind of a fork from the OS monitoring, which is a very lightweight thing. So even if you are using enhanced monitoring with 1 second granularity, it is not at all going to cause any major performance disruption or impact on your system. But if it is a very small instance like T2 micro, which is just having 2 CPU and maybe 2 gigabytes of memory, definitely will see some problem. So it depends on your workload, depends on the instance which you are using. Yep. Yeah. Yeah.
Similarly, enabling a lot of logs also does it have, or is it, where do we write the logs? The same storage.
Okay, I'll take that. So logs, yep. If I have to just speak specifically about MySQL and Aurora MySQL, all the logs are overhead. Probably something that's very light, I would call it as audit logs. If you're going to go with binary logs, it's an overhead. General logs, overhead. Slow query logs, overhead. Yes, it's a draw, like just balance between performance and your monitoring. So if at all you need monitoring, again, you need to like tune whatever you need. For example, like slow query logs, change the long query time to something bigger so that you don't log everything. So the amount of logging is minimal, that is only needed. And yes, go ahead with it.
What about Postgres?
Postgres.
So in Postgres, there are various log levels, right? You can select the verbose level logging, right? So if you are using the verbose level logging, it will create some overhead on the system. That is for sure. So what we always recommend for PostgreSQL, that unless your server is not running with some problems where you are not able to identify any issue, everything is running fine, do not go with the verbose level logging, because the moment you are using verbose level logging, it will consume some resources, not only resources, but it will also consume the storage space. That also you need to take care of. So it depends on your use case.
The query, standard query, temporary data, vacuum, all that.
That is fine. That is fine, because what I know that except the verbose level logging, whatever other things you are using, right, that is not going to cause any problem. Only the verbose level logging, I have seen that it can create some kind of performance over it. Yeah, sure.
In RDS, can you configure the logs to go to different partitions, different artists?
In RDS, no. In Aurora, yes. Aurora, the logs are not even stored on the common storage where your data is stored. So we have a separate storage volume which stores the logs. Yes. Yeah. That's good.
Yeah, just one general. Is there a way to find out how much energy is consumed?
How much energy means? Sorry.
What flux energy?
Power.
Electricity power.
Oh, okay. No, I'm not sure about that. Sorry. Okay. Yep. I'm sorry. Power consumption by the RDS infrastructure may be like that. That is a question for RDS or AWS billing, right? So we do have a separate team for billing on the AWS. So you can definitely go with the billing part. So to understand that, okay, which component of AWS is consuming what kind of billing for your.
We develop a solution, but we don't know how much energy efficient they are.
Energy efficiency.
Power consumption. If you want to use on-prem,
So
Yeah.
I think I can add few off-topic lines. So this is not the primary topic. But coming in the data centers, compliance on energy savings and all. For example, AWS has a commitment of net zero by 2030. That's like all our data centers, net zero emissions. That's where
I think he's asking from on-prem.
Yeah, both.
Not from the cloud.
Yeah, on-prem it's how you power your boxes. I mean, and it's not that a single process you can come up granularity. There is no instrumentation as such. For example, for a single CPU cycle, how much wattage would be used? I haven't seen that instrumentation in any of these devices. Yeah.
Certain databases use a different power consumption. So in that aspect, same thing. Is there any way to find out? Or any existing where AWS uses?
Okay, so this is obviously it's an interesting question.
It's an interesting question, but it's kind of off track, like off topic. I will try to do some more research on that, but to be very honest, I'm not so sure about it. I can openly accept that.
At least I'm not aware of any instrumentation.
About the power usage of the on-prem boxes which you have.
Yeah. No. This is not that anywhere. The database as a service, how much power it is consumed.
Like how
You
you
can
get in
talk about
MacBook
that
is what
later, but
you're-
not.
Yeah. How you get in MacBook is what he's asking. Like it's basically converting your CPU. How much for TDP what you have, right? For process you have TDP, right? They convert it and tell it watts. I think that's what you're. Maybe I didn't put it with the right thoughts. So you deploy each solution. We deploy software on that. So certain software consume a lot of RAM and usage, but certain applications consume less. But these issues are they running in your office or in Amazon? Then why are you worried?
Yeah, so what I'll add over here is that for energy related data, like we don't publish that for most of our services. So if you have a specific requirement where you need to know, what I will recommend you is to contact your account managers, and they will contact you with the correct team who will help you with this data. Okay, and like this kind of data, the data that you are asking, it's not really public, and we cannot tell you right now.
So one benchmark in our startup is that. So we run a lot of GPU workloads. So number of operations or GBs per second per GBs process per watt. So we want to create low carbon solutions. So in that area,
Yeah, even in AWS.
I mean, understood, and that's the overall commitment that I said. Our data centers would be net zero by 2030. That's the environmental commitment.
Yeah, and the other point is that even right now, different AWS regions has different carbon footprint. So if you are looking for energy per watt, like energy per CPU that is being used, that will be different, in terms of carbon emission in different AWS regions, right? So those data, up to some extent you can get, directly when you contact with your account managers. So please get in touch with them and they'll help you. Okay.
Thank you.
So we are drifting from the topic.
Yeah, exactly. So that's what I wanted to tell you actually. So this topic, it's really interesting. I can completely understand and agree with you, but it's not at all related to the database upgrade, right? So let's stick to the topic because we have a lot of things to cover, and maybe Demanshu, we can arrange a different talk for that, right? With the account managers or the TAMs. Fine, perfect. So coming back to the slide, we need to understand how you can get the maximum out of the RDS infrastructure. So we do have the on-premise databases. It can be on-premise, MySQL or PostgreSQL, SQL Server, Oracle, right? But on the other hand, we also have the managed services like RDS MySQL, RDS PostgreSQL, RDS SQL Server. So why do we use the RDS? What kind of benefit it is going to give you? One is like it is managed. You don't need to take care or you don't need to worry about how to take the backup or in what frequency you need to take the snapshot, right? Or how to do the maintenance. Amazon will automatically do this for you based on your configuration, right? But apart from that, apart from the simple topic of managing a database, how you can get the best out of the RDS infrastructure, that we need to understand. Because using this kind of concept, you can ensure that your data is completely safe, your performance is completely optimal, and the latency which you are getting for accessing the data, that can be kept as minimal as possible, right? So the first thing is like how you can make sure that your database is completely foolproof. We know that in Amazon, we have different regions, and in each of the region, we have multiple availability zones, that is AZ. So there is a concept called multi-AZ, that is in one of the region, if you are hosting a database, you can keep the database in different availability zones. That is the underlying EC2 instance or underlying EBS volume that will be there in various availability zone in the same region. So if one of the AZ is going down, definitely what will happen, the other AZ where your database is residing, that will automatically be up, right? So the amount of downtime or amount of data loss, you don't need to worry about that, right? So that is the multi-AZ. That is called a high availability solution. The second, if you are having very, I will say, read-only activity where multiple users are hitting your database server, and one of the database server or the primary instance, right, where you are doing the read and write operations, that is not able to handle the workload, what you can do? You can have multiple read replicas, and the read-only traffic, you can easily direct that to the read replica, right? Not only that, since the read replica means Amazon is taking care of the replication from the primary instance to the replication instance. In case your primary instance is going down, you can quickly make that replication instance up and running, which is going to serve your as a primary instance. So again, the amount of downtime, it is going to be very, very less, very, very minimal, right? So that is the read replica. In case if you are trying to set up the replication manually in the MySQL, you know that you need to execute multiple steps, take a backup, restore, take the bin log position, check the relay log position, then check the gap between the bin log and relay log to understand if there is a gap in the replication or there is a lag in the replication. But if you are creating a read replica, with just a single click, Amazon is going to take care of you, right? The RDS infrastructure is going to take care of that. So it is that simple. Apart from that, as Niranjan mentioned, right, in the previous slide, that how you can understand whether your database is performing optimally. We do have the CloudWatch metrics, which are free, right? But apart from that, we also have the granular level of metrics like enhanced monitoring, where you can configure as minimum as 1 second. And also we have the performance insight where you can see the database level metrics. That is, what are your weight types in the database? Or what are the queries which are consuming maximum amount of resources, which are the possible candidate for the query tuning, right? So these are the monitoring softwares which we have. apart from the traditional MySQL monitoring utility. But to use the traditional MySQL utility for monitoring or for the performance tuning, you need to understand how it is going to work. But with the performance insight or with the enhanced monitoring, it is going to present a pictorial representation, a graphical representation, using which you can easily understand, okay, these are the queries I need to attack, right? Or this is the weight type I need to understand. So that is the beauty of the RDS provided monitoring software like enhanced monitoring or performance insight. And as I talked about read replica, we also have the cross-region read replica. So what is the cross-region read replica? Maybe one of the instance is residing in Mumbai region, right? And you have your workload or the application hosted in India as well as hosted in, think about Australia, Sydney or Melbourne. So the application which is hosted in the Sydney or Melbourne, the Australia side, if that application is going to query the database, what will happen? It needs to traverse the internet and then come to India, Mumbai, and then get the data. Again, take the data back to Australia. So it is going to take a lot of time. You will see a huge latency in the read workload. So if you have the cross-region read replica where your primary instance is there in the India region and your cross-region read replica is there in the Sydney region, Australia region. So what will happen? The reads which are coming from the Australia application, you can easily point that in the instance which is there in the Australia region, right? So the latency of the read, it is going to be very minimal. So that's how you have to design your database architecture. You have to design your application architecture. Based on that, just 1 minute. So based on that, you can configure how your database should look like, and then you can take it forward to minimize the latency and everything. Yeah, sure.
If you host the read replica in Australia, the application is very near to that. It works fine. But the distance between India and Australia will cause some latency, and it will be like real-time guarantee of the data is replicated from India to Australia. There will always be a gap, right? Do you have any guarantees over here that?
Okay. To answer, I'll cover this again with Aurora, but here in RDS MySQL, answer is no. How exactly we are setting up cross-region read replica? It's again making use of bin log replication. So bin log replication, like the normal bin log replication. So again, the physical distance, like you mentioned, it's indeed going to have the latency. It's indeed going to contribute to the lag.
When you say RDS MySQL, that is Oracle version of MySQL or what?
So, okay. RDS, again, we kind of like don't change the source code of MySQL. We take MySQL source code and then we kind of just modify to make sure that we give it as a managed service for you. But the underlying MySQL code still remains the same. Probably the code like something like creating new stored procedures to give you additional features or restricting few permissions so that you don't break the system eventually. Something like this is changed. But
let me ask this in a different way. If a patch is coming from Oracle MySQL, can I expect that for RDS MySQL also?
Yes. So the patch would be coming for a specific version. Again, RDS would incorporate it and release that version soon.
The connected one, like read Sydney and India. You could also set up a multi-AZ in India, and of course, write will slow down because it's a sync write.
Okay, so region and AZ are different basically. So region means in India we have Mumbai, right? So in Mumbai we can have multiple AZ. Similarly, in the Sydney region we have multiple AZ, right? So when I'm talking, correct. Yeah. Someone, yeah.
Yeah. So basically, for multiple availability zones, we have replication as the main process that takes place. Is there some sort of sharding involved as well?
So sharding is basically application design. It is not a database design, right? So if your application have a requirement of sharding where you want to break your data in multiple shards, that definitely you can define in the application layer, and your database will be laid out in that format, right? But in case if you are having a shard in one of the region, that shard will automatically be replicated in the second region if you have the read replica, right? So when I'm talking about read replica, it is not only the data, but also the database format which you have.
MySQL supports a multi-master sort of a setup. You both support that in RDS or Aurora?
So Aurora indeed supported multi-master, but it's getting deprecated. And RDS multi-master is not yet supported.
Okay, so if you want to support like a cross-region multi-master or something, that's not possible in Aurora, right?
Not possible. But then again, though it's not a foolproof solution, if at all you can manually configure replication and the circular replication, yes.
So I think you are comparing with Oracle RAC.
I know that MySQL has a multi-master supported.
Yes.
That's Galera MySQL, I guess. Right? That's Galera MySQL.
Yeah.
Correct.
No, it's not supported.
Sure.
So it's mainly about.
So how does that application in Australia, how does it go? Is it based on DNS or something on the network? How do you respond to the people?
Okay. So any instance, it is having an endpoint, right? If you talk about RDS MySQL or if you talk about Aurora MySQL, every instance is having an endpoint. So when you are connecting to that instance, be it the primary instance, be it the read replica instance, you need to configure the application connection string to have that endpoint, right? And that endpoint needs to have the security group, network access control list, the route table properly defined, right? So it depends on the endpoint. Like whatever endpoint you are having, you just need to specify in the connection string. If your security group, access control list, route table, everything is properly configured, you will be able to connect.
And another application from the option is the master how the how does it happen? Based on DNS, get a different IP.
Sure.
So basically, you need to point to you need an IP of the IP or DNS of the slave, right?
So
Nothing is something you need to provide an address. So you provide the address of the slave. It's as simple as that.
So
in where no, okay, I'll probably clarify. Application will not automatically go and connect to the no, there's no one single endpoint which is going to go to both. You need to configure your application for each of the endpoints.
As I told, right, that every instance is different. It can be the primary instance, read replica instance, anything. Every instance is different. You have your DNS server, or you can use the Amazon provided DNS server where the name and IPs are mapped, right? So as he mentioned that either you can connect with the IP address or you can connect with the name of the instance, right? IP address can be the private IP, it can be the public IP. It depends on what kind of network you are using. Someone.
Hello.
I'm sorry. IPs can change, but you also have the concept of elastic IP, right? That will be same, right? So it depends on your application. Like if your application is not fault proof, then definitely you need to configure the application or the IP address in such a manner. Yeah, sure.
Yeah. So RDS is telling that MySQL. So there are other versions of SQL. Can you bring the customers bring their own preferred SQL drivers to build upon RDS? Like maybe Gigabyte, there's a new distributed SQL database.
Okay. So that's an interesting question actually. So RDS means it's a managed database, right? So when it is a managed database, Amazon is managing on behalf of you, correct? Like the backup or the installation, upgradation, everything is Amazon managed. So if you are bringing your own binary in RDS, no, that is not possible. But we do have another flavor called EC2, right? So Elastic Compute Cloud, which is kind of a VM. So on the EC2, you can definitely install the MySQL software, or you can use your own binary to build up the database, and then you can use it. But that will not going to be the managed database. You have to manage the like backup or upgrade or whatever on from your own.
Yeah, that. So this is a managed database service. So there is no existing facilities to bring their own. I mean, it's not bring their own, kind of pick open source, maybe Lightstream, other database versions to enable manage without reducing burden of global replications.
So again, if I've understood your question correctly, so if at all you're going to go with RDS, we have set of predefined engines. So you can use those. Again, MySQL, Postgres, Oracle, SQL Server, TimeStream, Aurora. You have all of this. But yes, it's only these, like 6 to 7, a small list of database engines which are supported in RDS. So when I say RDS, again, the managed service. Anything beyond this, no.
Okay, if you want to use beyond that, as I told you, have to use the EC2 instance, and on top of that, you can build your own database version.
Case of EC2, so then it comes down to VPC peering. So you launch.
It comes down to, sorry.
Launch multiple instances in different regions, different availability zones based on the requirement. Then you connect it with peering. So each zones have their own VPCs.
See, yeah.
Yeah.
I'm an ex-Gigabyte guy. Gigabyte automatically does what you're talking about. It creates view in different regions. It does the VPC peering all the by itself.
Gigabyte cloud it will do. So if you
Okay, yeah. Let me quickly answer the question, then we'll move to the next slide. Sure. Fine. Let me take the question. It's a very simple one, actually. So even if it is EC2, even if it is RDS, right, you have the underlying networking configuration that is called a VPC, right? Virtual Private Cloud. So in Amazon, regardless of you are using EC2 instance or the RDS instance, you have to keep that in the VPC, right? So after that, within 2 VPCs, you can set a VPC peering, or you can use your direct connect. Multiple networking configuration is there. So that depends on your application, right? What we are providing, we are just providing the infrastructure of RDS and EC2, right? And after that, you can tweak your application code to connect to the RDS instance or execute any queries. That depends on your application, right? So that's why you always call that it is kind of a shared responsibility model. Amazon is going to take care of managing the database, and you are going to be responsible for connecting your application, tuning the queries, executing the queries, these kind of things. Yep. Okay.
Yes. Okay. Coming back to the slides. Okay.
Sure.
Yep. So, okay. We just spoke about what exactly we can do to get the maximum out of RDS. So again, when it comes to Aurora, whatever we discussed with respect to RDS holds good here. Like for example, the monitoring, everything holds good even here. But apart from that, Aurora gives more advantages as well. Again, for example, adding reader instances. We spoke about adding read replica there and multi-AZ there. Multi-AZ is for high availability, read replica for distributing your read workloads. But here, it's just a single concept of reader instances. You can have up to 15 reader instances within your Aurora cluster. So 15 reader instances, all these reader instances will help you distribute your read workload and also act as your failover target. So if the primary instance is down, one of these reader instances will come up as the writer. So again, high availability and distributing read workload. Yes, it will be spread across multiple AZs, and you get to choose the AZ that you want as well. So you have probably like 3 AZs within a region, or the reader instances can be in any of the 3 AZs. Yep. And probably not exactly the same question like what was asked earlier, but here we have a common endpoint for the reader instance. You use a single endpoint and you'll connect to all the reader instances in a round robin fashion. So workload gets distributed to all the reader instances in a round robin fashion. Again, probably if I have to correct myself, it's not workload, it's connections. Because it's endpoint, it's a DNS. So it's just the DNS resolution that's going to happen in a round robin fashion. Yes. Now coming to global, okay. Before going to global cluster, again, these reader instances are not replicating via binary logs. So these are infrastructure level replication. So you'll see the latency or the lag to be typically around 25 milliseconds. So all the reader instances will be in sync approximately within 25 to 30 milliseconds. Again, it can spike up based on the workload that's happening on the writer. But yes, typically around 25. Now coming to global cluster, we use a similar technology here, like how we do it for reader instances. Again, infrastructure level replication to other regions. So you have a cluster in the primary region, you have a cluster in another region, and they're replicated via the infrastructure and again, not via binary logs. And what we give as a promise is that again, typically the lag here is 1 second. again, when there's a huge workload, it can indeed go up. But then whenever there's the normal workload, there's no spiky workload, it's going to be typically less than 1 second. If you're going to monitor the graphs, you'll see that it's somewhere around 100 milliseconds, 120 milliseconds. That's how it is. So adding readers is going to distribute your read workload, adding global cluster, again, distributing workload across regions, and also disaster recovery. One of the region goes down, you can immediately bring up the other region as your primary, and that's done. You can still continue to serve your traffic. And yes, I spoke about serverless in my initial slides. So serverless, if at all we have a workload that is spiky, we don't know whether we need to go with 4 cores of CPUs, 24 cores of CPUs, 16 cores of CPUs, go with serverless. Or if you have the necessity of having 4 cores in the morning, 16 cores in the evening, 20 cores at night or something like that, go with serverless. So it will scale up and down, and it will serve your workload. But this might not be suitable if at all you constantly need 4 cores of CPU. It's just going to prove to be expensive. Yes. And the last option, again, this is something that's new that was launched. So we have zero ETL, which is nothing but the analysis of your workload. So whatever workload that you have on your database is, again, the DML operations are returned to the transaction logs, that is binary logs. And you can analyze these binary logs using Redshift. And you can analyze this data to understand how exactly your workload is happening on the database. To run analytical workloads, probably all these years, engineers or users were probably just trying to run it on one of the reader instances. Now you can directly put it to Redshift and it will do all the magic for you. Yes, please.
Scale up, scale down, is there any latency impact?
Scale for serverless? No, it's very, very quick. So you're gonna have workload. It scales up with a granular of 0.5 ACUs. Each ACU is something equivalent to 2 GB of RAM. So each time there's a workload, it will scale up seamlessly because yes. Yep.
Okay. So this is kind of a, I will say, generic slide or generic topic. So I will try to cover it in a high level overview, because any database upgrade, you know that it can create multiple problems. And for that, we need to have a proper testing in place so that we can avoid the future problems during or after the upgrade. Right. So there can be multiple difficulties, multiple, I will say, testing. So let me quickly try to cover that in a generic way, what you can expect during the upgrade process, or before or after the upgrade process. Right. So as we know, there can be 2 types of upgrade. One is called the minor version upgrade and one is called the major version upgrade. So if it is a minor version upgrade, so for example, MySQL 5.7, there can be different version, 5.7.9, 5.7.12. These are called the minor version upgrade because you are keeping the base MySQL version same and maybe fixing some of the bugs or this kind of thing. And the major version upgrade means you are upgrading from 5.7 to 8.0, right? It is not only true for MySQL, any databases, whatever you know, that is those databases are having these kind of 2 different upgrades, major and minor. So what are the differences between major and minor? Generally, minor upgrades are kind of backward compatible. So backward compatible means if your application is using one specific version of MySQL, let's think about 5.7.9, and you are doing the upgrade from 5.7.9 to 5.7.12, you can be sure that your application is going to work as usual. There will not be any problem because already it is having the backward compatibility. But if you are using the major version upgrade, that is 5.7 to 8.0, you need to be very, very cautious because with every major version upgrade in any of the database vendors, SQL Server, Oracle, open source like MySQL, PostgreSQL, they deprecate a lot of things, they fix a lot of bugs, they implement a lot of new features, right? So that is the major version upgrade. So we need to take proper precaution. I will not use the word proper. You need to take utmost precaution before you schedule a major version upgrade. And that can take a lot of days. It can be like weeks or months, or I will say 2 months, 3 months before you do the planning or testing or before you schedule the actual upgrade on your production instance, right? I'm talking about major version. So some example, right? Like we know that there's a very famous MySQL configuration, InnoDB flush log at transaction commit. That is the frequency when the logs are going to be flushed to disk, right? With every commit or every 1 second, There are three values, 0, 1, and 2. It depends on the ACID property, like how you want to prove or how you want to prevent your application from losing any data. Right. So that InnoDB flush logger transaction commit, that is a valid parameter in 5.7, but in 8.0, it is not valid. Correct. So these kind of things, in case if you're using InnoDB flush log a transaction commit in your application code in 5.7, but if you are planning to upgrade to 8.0, you need to know what are the parameters those are going to be deprecated in the next release, right? So this planning or this kind of testing, it needs a lot of effort. So you may need to set up a test server, right, by taking a snapshot from the actual production instance, restore that. In the restored instance, you do the upgrade of from 5.7 to 8.0 or whatever, then create a dummy application, whatever you are having in your office, point that dummy application to the restored upgraded server, and then check if your application is working properly. Right? You may need to simulate the workload which is there in your actual production application, right? Maybe you can use tools like Sysbench, or you can use tools like MySQL Slap, where you can do some kind of load testing and then see that whether the restored upgraded server is working properly or not. Other few problems can be, we know that when we are doing the MySQL upgrade, there is a requirement or there is a need to rebuild the tables. It can be the rebuild the system tables, rebuild the user tables. And we know that whenever we are going to rebuild the tables, it can take or it can consume a lot of space, right? So you need to have a proper free space available in the database server before you perform the activity. Right? Otherwise, your upgrade can fail. Or maybe if your application is running and your database is getting constant transactions, right? Constant data modifications or insertion, deletion, whatever. A lot of uncommitted transactions are there. While doing the upgrade, definitely what will happen, MySQL will go down. Upgrade, it will come up. Right? So while the database is going down, we know that we maintain the ACID property, so the crash recovery, everything will take place. So that can also take a lot of time. So it definitely needs a proper testing. Do not rush. That is going to be my suggestion. Take some time, create the test server, upgrade that, point your application, simulate the workload, and then only perform the upgrade process. Right? Yeah.
For a read replica which is connected to this primary, I think whatever operation you are performing on primary, they are automatically.
Yes. Yes. Correct. Right. So that's why actually it's a very good point. And to reduce the downtime, if there is any problem in the upgrade process, this read replica or the blueprint deployment, and Anjali is going to talk about that. These are very handy operation, right? The downtime, amount of downtime will be very, very low. In case there is any problem, you can easily recover from the problem. Yeah. So like what I told, right? Avoiding surprises. Basically, it is kind of a version of the previous slide. Avoiding surprises means if you are not testing the upgrade process, right, before upgrading the actual production server, you can see a lot of problems after the upgrade. Like, for example, we know that the moment you are doing the upgrade from 5.7 to 8.0, some of the important queries in your application, it can have a different query execution plan in the next release, in the next version. So if the query plan is different, then what will happen? The query can take time. Query will, means you will see the query is not giving the result in a proper manner, right? Your application will be using, your users will be screaming, right? So definitely this kind of testing is very, very important. And one more thing is like some of the, okay, so one more thing, like in 5.7, we do have a component in MySQL that is called query cache, right? What is a query cache? Whatever query you are executing, it will cache the data, cache the result. The moment you are re-executing the query, it will immediately deliver the result back to you. But from MySQL 8.0, we completely disable the query cache. It is not something like RDS specific. It is a community MySQL version specific. So if the query cache is disabled, what will happen? Even if you re-execute the query, it has to go through the same process of like validating, then query plan, then fetching the data from the data disk, and then it will present the data to you. So Upgrading from 5.7 to 8.0, where you do not know that query cache is disabled, what will happen? You will be surprised. What happened? Why my query is taking time after the upgrade? And then you will open a case with maybe MySQL community version, or maybe with RDS that, after upgrading, I don't know, something happened. All my queries are taking a lot of time. Right. So to avoid the surprises, do the testing, understand what are the differences, and when you are convinced, then only you perform the upgrade in the production server. Though, yeah.
Read replica and then just one at a time.
Niranjan will talk about that, the upgrade process. Okay. Yep. And in Amazon or in RDS, as I told, it's a managed server, right? It's a managed process. If you want to upgrade, it is just a single click. Select the instance, go to the actions, upgrade, provide version, it will upgrade. You will think that, okay, if it is that simple, why do I need to have this kind of testing? Or why Sandeepan is talking about avoid surprises, do this thing, do that thing, why? The only thing which you need to understand, or which you need to keep in mind, that RDS is giving you the button to upgrade that, but RDS is not taking the responsibility that after the upgrade it is going to working fine or not. So that you as a DBA or you as an application owner or application architect need to understand, do the proper testing, then use the RDS single click feature to upgrade the database. Yeah.
That we have to recreate all these.
Exactly. It's right. Okay. Yeah.
Why not there is an assessment provided by this cloud provider for upgrade? So they can say that
Okay. Yes, we indeed do that in Aurora, but then this is not an exhaustive list. So in Aurora, when you perform an upgrade, we give a customized version of pre-check log saying that, okay, you have these configuration, you have these type of tables, you have these type of data types, etc. And this might cause problem if you upgrade. We give this. But again, the major concern that we have now is, for example, a simple select that you're going to run might not have the same execution plan on 5.7 as same as 8.0. Why? Optimizer is completely changed in 5.7 and 8.0. And second, like Sandy mentioned, so we don't have query cache. So it's not just about performance, but even resource. When you speak about query cache, it's nearly 0% CPU. You go, you get back the results. But in 8.0, again, we don't know what all queries were being served from query cache all these days. Now, I don't know, again, what would happen after you upgrade. And at that time, resource utilization would pick up, probably, yes. And then slowness, and it's going to impact. So we are trying to like include almost whatever is possible from our end in the pre-checks. But then, yes, it's really not an exhaustive list.
For RDS,
RDS, we have the, whatever we have it in the community MySQL, whatever, the basic data types and stuff. But yeah, Aurora has a customized version of it. Yes. And this is very important. Whenever we speak about our testing, what everyone feels is that, okay, I need to probably test the upgrade process to see whether the upgrade goes successful, whether the instance is healthy after upgrade. Boom, I'm ready to upgrade. No, that's not something that we should be doing. After the upgrade, like Sandy mentioned, we need to be looking at whether our queries and the application is behaving properly. And yes, one useful tool that we provide is RDS blue-green deployment, which will, again, it is nothing but bin log replication again. But yes, we have a lot of guardrails around it. So you create a new read replica using this blue-green deployment, and that green deployment is going to be a test environment where you can run your test workload, you do all the magic, you do all the testing. And if you're happy with what you see on the green, you can do a cutover. And while doing a cutover, you also get an option to choose what is the downtime that you want. If the downtime is expected to go beyond that, the upgrade will just roll back. If at all the downtime is possible within the time that was specified, then the upgrade proceeds. So if at all this blue-green deployment wasn't there, yes, probably all these years before blue-green deployment was made available, we would suggest customers to use RDS read replica, upgrade the read replica. Like you asked, we can just upgrade the read replica and then manually do a cutover. But yes, like we spoke about the endpoints as well. Each instance will have its own endpoint. So when you cut over, the new instance will have its new endpoint. But again, the blue-green deployment takes care of that as well. You do a cutover and your application will directly point to the new blue environment, I would say. So you need to test it this way. But yes, blue-green deployment doesn't give you a rollback mechanism. You go to the green as blue, done. You're on the new version. But is that sufficient? No. As an engineer who's working constantly on issues related to upgrade should always have a rollback plan. So a simple rollback plan that I'll be discussing in the next slide is about setting up bin log replication again from the new green or the test instance with the older version. Again, though not all versions are supported for the backward compatibility, but then yes, this is the best bet that you can get. So you're moving from 5.7 to 8.0. Blue is going to be 5.7. Go to green, that is 8.0. From 8.0, you have a replication going to another 5.7 instance again. So you need to probably test your workload on 8.0. And when I say test your workload, you're pointing your application to 8.0 temporarily for a week or 2 weeks. And you're happy, you can probably cut over. Else you're not happy, you have collected all the information, go back to the 5.7 instance. Now you have the information to troubleshoot, analyze, and then again, reiterate this, keep doing this again in iterative circles until you're really happy with 8.0. This might be a very cumbersome process, but then this is going to be something that's going to help you ensure that your application isn't down. This is very critical. Yes, please.
Does RDS now provides proxy, right?
Yes.
Does RDS proxy do anything?
Okay, RDS proxy will help you again reduce the downtime. What would happen? RDS proxy is a bit smart. It will help you ensure that whenever there's a downtime, it will park your connections. In very simple words, though I'll not go in depth about RDS proxy, you have a layer which is going to park your connection when the database is down. It will not drop your connection. It will just hold the connection for some time. And then when the database is up, it will directly send those connections there, giving you a picture that the downtime is very low. So whenever we are performing upgrades and stuff, the downtime that your application faces can be minimized using RDS proxy. No. Yes.
And how does RDS proxy use replicas?
In replicas in the sense, sorry. Yes, please.
Sorry, quick time check. How many more? This is the last one. The last one. Means after the
Next one is the last one.
So you mentioned that in blue-green deployment, we can mention the downtime, and if that is feasible, only then it should be the green of the latest. So what happens in that mechanism?
Okay, so there are a lot of code lines that actually checks this, but to probably like give you one simple example. Again, like I told, blue-green is again bin log replication. So if the lag itself is something greater than what you have given, it will directly say no. Your replica lag itself is greater than the downtime that you have specified. So okay, whenever I need to promote, I need to ensure that the green is in sync with the blue. So the lag should come to 0. And if the lag is, let's say, 2 minutes, and you give the downtime as 1 minute, the lag will take 2 minutes to come down. So it will directly say, I'll not even upgrade. So wait for the lag to come down. In a similar way, we look at, again, how many tables that has to be rebuilt. Again, just the normal prechecks that I told, which we have as the list of elements that we'll be checking. We'll look at those things to see if at all that's going to consume more time. Again, it's just, yes. Yeah.
We used to do the manual blue-green deployment, but we used to flip only to blue back when the green doesn't work. But we have deployed it already. Here you are saying without deploying it to green, we can check based on the downtime.
Yes.
So is it kind of dry run at the back end that it runs?
No, it doesn't do a dry run. It's just an estimate that it makes along with looking at the replica lag. That's it.
So very simple thing. Do not set that timeout value very low. You have a RTO, right? Recovery time objective in your application, which is defined. So set that value as RTO. right? And you know that if it is going to be failed, that means you are not able to meet your RTO. So you need to tune the upgrade process. You need to tune the queries or parameters, right? Again, set the RTO value equal to the timeout, and then again check it. As simple as that.
Limited to databases, or we can have blue-green deployments from Amazon to other services as well, or other application deployments as well?
Many services have this kind of blue-green kind of thing, but then whatever we are speaking about is just dedicated to RDS. Yeah.
This blue-green can be used for even the storage upgrades also?
Like you can use it even for your database testing as well. For example, you want to like perform an alter table. You don't want to do it on production. Create a blue-green deployment, run alter on your green, do a cutover.
During normal deployments also we can.
Yes, you can use it for any testing purpose. Let it be at the infrastructure level, let it be at the engine layer. Do it there, do the cutover.
We can also roll back?
No, we cannot roll back. Yes.
We can take this offline. Okay, I'm sorry, actually. Yeah, please.
Yes, I'll just quickly speak about one more point. Sure. Yes. One important thing about the engine is the parameters. So even if you're going to go with the default parameters, looking at different versions, the default parameters itself would be different. So the default parameters being different will contribute a lot to your performance. Again, one simple thing is, like I mentioned, optimizer. And the parameter or the configuration parameter for optimizer is optimizer switch, which decides what is the execution plan it has to take, which decides how exactly the query has to be executed. And these are different between 5.6, 5.7, and 8.0. And again, the end users tend to miss looking at these parameters. So look at the parameters and perform these testings. And when you're like really confident that the new version is really working as per your expectation, then remove the old version from your setup. Till then, you should always have your old version. And yes, make use of the monitoring that we just discussed in the very initial slides to see the resource utilization, performance, everything. Compare it between the two servers to understand whether it's good or bad. Yes, I'll quickly run through it again. This is a bit of a continuation of the previous slide, but apart from making use of the metrics, CloudWatch, enhanced monitoring, and performance insights, you will also have to make use of the database or MySQL DBA queries, I would say. All the queries that is needed, for example, explain, to look at the explain plan of the queries. Simple, whatever major queries that you have or the important queries that you have on 5.7, check the execution plan on 5.7, check the execution plan on 8.0. Things are not in the way that you're expecting. That's something that you have to tune before you move to the newer version. What is profiling is going to give you the list of stages or the events that the query will undergo. Did it read through query cache? Did it go hit the disk? Did it like spend time waiting for the log? Everything is given in profiling. So you see a query running slow on the newer version, look at profiling, compare it again with the older version to see which stage is taking longer on the newer version. Use this information, again tune, again do the iterative circle again. And yes, InnoDB status and global status, I'm assuming that we are all aware of this. This is the normal DBA queries that we run to understand what is happening inside InnoDB. Whether we are hitting the buffer pool, what is the usage of buffer pool, what is the usage of redo log, to what extent the redo log is growing, what is the semaphores that is happening, are there any logs on the database? Again, log, semaphore, both are displayed there. So yes, use this whenever you're seeing problems with respect to the newer version, run it even on your older version, compare to understand what is problematic, and we need to resolve this. Yes.
Okay, and apart from that, we do have a like traditional DBA queries, right, using which you can monitor the performance of the databases, like what Niranjan mentioned, DB status, and apart from that, DB TRX, DB logs, DB log weights. So after you perform the upgrade in the test server, make sure that you are simulating your workload in the upgraded instance, and then execute these DBA queries to understand if the performance is optimal or not, if there is any blocking going to happen or not, if the objects are waiting to acquire the logs or not. So all these things, when you are completely satisfied about the performance in the test upgraded server, then only you perform the actual upgrade in the main production instance. That is the bottom line, which we need to be very, very clear about. Okay, and trust me, as I told, right, we handle a lot of cases in MySQL or any other databases. Multiple problems we are getting from the customers where just because the lack of planning, the upgrade either failed or the upgrade created a lot of problem in the upgraded instance when the application is pointed. So the suggestion is like, do the proper testing, get yourself satisfied, and then only perform the upgrade in the actual instance. That is the bottom line. Yep, that's all we have. I know we took some time. Apologies for that. It's clearly understandable because database is the most important thing. Again, apologies. Thank you so much.
Thanks, everyone.
Hey, thanks a lot, both of you. I think this is one of the most interactive session in the recent time. Please don't forget to share the AWS codes. Okay. So we'll take a quick lunch break and then we will assemble. We all need to go to the fourth floor.
Yeah, 2 o'clock.
Yeah, 2 o'clock we'll be back here.
Other taking a
Yep. So fourth floor we will take the stairs. Okay. I'll come there in the front and guide you guys.
Hey, how is it? Is he here? Yeah, he told he'll come. He'll come. Yeah. I just messaged him. Yeah, thanks. He was not talking about it, but which short you are.
This is not enough, enough. It's giving. Ooh, ooh, it's giving. Can even express myself. It's been a while, I haven't seen you smile. Can even express myself. Streets in the morning, the sun shining bright, and I'm watching your touch. 6 in the morning, dancing in the streets from this play. Oh, I know you're fading, but stay, don't close your hands. I wanna make this play. I know you're fading. Oh, but stay, don't close your hands. I wanna make this play. I wanna make this play. But stay, don't close your hands. But stay, don't close your hands. I wanna make this play. Oh, but stay, don't close your hands. I wanna make this play. I wanna make this play. Don't waste any time, yeah, you've been on my mind. There from the start when my heart became yours, don't say we're over. Don't waste any time, yeah, you've been on my mind. There from the start when my heart became yours, don't say we're over. Here with me. something looking for, something that would give me peace of mind. You make me insecure, I pretend that it's good when I'm not. What do you think about it? 'Cause I'm dying, baby. If you want it, it's just hard to take it. If you feel something, boy, you gotta tell me. No, I'm lying. Yeah. 'Cause I'm hurting, 'cause I'm bleeding, going crazy. I need you, just cut me. You don't help me. Yeah. You don't help me. You don't help me. You don't help me. You don't help me. 'Cause I'm hurting, 'cause I'm bleeding, going crazy. I need you, just cut me. You don't help me. What do you think about it? 'Cause I'm lying, baby. If you want it, it's just hard to take it. If you feel something, boy, you gotta tell me. No, I'm lying. Well, I've gotta say, I am feeling overwhelmed. 'Cause I've been trying so hard, trying to feel anything. Maybe I just realized, baby, you're not the one. We're running out of time. I just wanna enjoy my life. I'm sorry, I'm done with you. I gotta run away. Don't wanna waste more time. I'm breaking up with you. Know what people say. If you love someone, just let them go. But I don't love you back. I'll let you go, go anyway. I can see it clearly now. Baby, you're not the one. Our relationship just died. I'm gonna enjoy my life. I'm sorry, I'm done with you. I'm gonna run away. Don't wanna waste more time. I'm breaking up with you. This is a breakup song. This is a breakup song. This is our breakup song. This is a breakup song. This is our breakup song. This is our breakup song. Every time the sun goes down, when your hair turns cold and brown, grab your hips, close my eyes, like a tree once in a while. Let me feel this one more time. This one more time. Memories all by your side. When you're around, when you're around, when you're around. Gasolines inside my eyes, in my soul and mind combined. I don't know when it was, but I feel inside a blend. Suddenly you own my heart, you own my heart, you own my heart. When you're around, when you're around, when you're around, you own my heart. Love to see you there laughing in the mirror. Love to see you there laying down with fever. Love to see you there being so creative. Love to see you there anyway. You own my heart. You own my heart. You own my heart. You own my heart. When you're around, you're around, when you're around, I can feel the pain going down the river, like a moon that shines all the dark night. When you're around, when you're around, when you're around, this is love I won't deny. This is love I won't deny.
I'm low, 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 lost. I swear I will be better than I was. I thought that I was special and we will be together. Now I'm low, 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 lost. I swear I will be better than I was. I thought that I was special and we will be together. I'm low, 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 lost. I swear I will be better than I was. I thought that I was special and we will be together. I feel just like a fool inside. I found a stupid
I'm done playing. Pour in the rain, yeah. It's blood in my face. I love on my face. I'm done playing, pouring the rain, yeah. It's blood in my face, all over my face. Every now and then I feel so alone, trying to get some inspiration to turn me on. With every word I say, with every step I take, feeling in the darkness, black as night can be, black as night can be. Every word I say, with every step I take, feeling in the darkness, black as night can be.
Yeah. Hello. So this much level is fine, or we can increase? This is fine. Okay. Thanks.
Hey guys, good afternoon. I'm Santana. I spearhead the business development of MyDB Ops. So currently, we provide precisely the support for databases, irrespective whichever it is that are open source, which could be MySQL, Mongo, Postgres, TiDB, Maria, and we're also recently ventured into Yugabyte, Cassandra, Couch, and ScyllaDB. As you know that most of the things, as previously mentioned, right, it's all taken care in the cloud, where in terms of monitoring, in terms of backups, but there are a lot of things in terms of operation perspective that you really require the expertise in terms of query optimization, performance improvement, whether you need to have a proxy SQL or not, whether you need to drop the unused index or the right set of index has to be there, or to monitor even to the InnoDB metrics also as well. So that's where we have the expertise, and we support almost all the kingpins in India. That includes companies like Flipkart, Swiggy, Dream11, Big Basket, Nykaa, Paytm Bank, and many, many more. So that's exactly pretty much that we do. And if you have any questions on something about what we do and how exactly we work, and I'll be more than happy to answer about it.
Thank you. Thanks for the praise.
Thanks a lot.
Okay.
Thanks. I think we will start the next session. We're going to discuss deeper on the CI/CD pipelines for multiple architecture and environments. Santosh Kumar from AWS will be explaining us and walking through us.
Super. Thank you. Thank you. Am I audible properly, right? Okay. So yeah, so I'll talk about like how do you re-engineer your CI/CD pipeline for multi-arc environment. So multi-arc is becoming a new reality these days. When I say multi-arc, it's basically using compute for your workload based on multiple CPU architecture, right, of underlying server or underlying VM, whatever you are using. So I'll talk about that. I'll basically tell you, like, when you go into your production with multiple architecture, what are the considerations that you will have to make in your CI/CD pipeline to ensure that the change is smooth for you and it is consistent, and it is not giving you any surprises or problems when once you change the CPU architecture for your application, right? So about myself, my name is Santosh Kumar. I'm part of AWS. I am a senior specialist solutions architect for EC2 Graviton. So my day-to-day work basically, revolves around helping customer or assisting customers adopting Graviton servers as part of their workload, basically, like migrating workload or assisting if a workload can be migrated to Graviton, or if there is a performance issues, how that performance issue can be troubleshooted and how that performance issue can be fixed. So those kind of day-to-day activities what I handle. And I specifically handle India market. I have a BD business development with me, and we together handle India market. Okay, overall for Graviton business of AWS. So that's about me. Then to start with, I'll give you a quick overview of Graviton processors that AWS has. I'll kind of give you a very high level overview of what it is, what are the benefits, and why you should be using it. And if you want to use it, what are the process of migrating your workload to Graviton. So I'll quickly walk you through it. I have done this talk already in my 43rd LSP event. So it's already there, recorded video. So if you want to go in detail about it and walk through it, you can definitely check that video. I have a link as well over here that I'll show you. But in this session, just to ensure everybody is up to speed, I'll walk you through very quickly. So talking about Graviton servers, AWS Graviton is basically a family of custom designed general purpose processor, built on ARM64 CPU architecture. Okay, and it has got targeted optimization to enhance performance of cloud workloads like databases, in-memory cache, or microservices, or any other database or any other workload that you can think of. Okay. So Graviton powered processors basically can help you, lower TCO, total cost of an ownership, very significantly, because Graviton processors or instances, EC2 instances powered by Graviton processors are 20% less expensive as compared to other x86 instances. In Mumbai region, Mumbai and Hyderabad, both regions specifically, it is 50% less expensive as compared to other x86 instances of similar size. Okay. In Graviton processors also provides best performance as well as best price performance for the broad array of workload. Along with that, it also uses 60% less energy when compared to similar size other EC2 instances. Okay. When talking about workloads, it supports, as I mentioned, a broad range of workload, including web and gaming servers, high-performance computing, media encoding, analytics, microservices, electronic design simulation, in-memory cache, databases, and more. Okay, these are some examples that I have provided you, but any workload that you can think of, which is not restricted by the vendor licensing, can work on Graviton processors at this time. This is a quick snapshot of how much effort you will need to port a specific workload to instances powered by Graviton. When you are starting with, when you want to start using Graviton and the Graviton adoption journey basically for your organization, and if it is first time for you, then we generally recommend you to start with AWS managed services. There are a lot of managed services that supports Graviton, including RDS, Aurora, Elasticache, Elasticsearch, MemoryDB, and more. Okay, so all the RDS or any other managed services, right? The upgrade process that my colleagues has talked about in RDS session, you'll have to follow the same process of migrating your workload from one architecture to other. But if you just talk about the migration process as the DB version upgrade, major version upgrade was single click. Here also the migration from one architecture to other architecture will also be very easy. Few clicks, not single click, but few clicks on AWS console, and you will be able to migrate to Graviton based processor nodes. Okay, but you will have to do your own planning. Plan about when you want to do migrate, what other changes are required, if the performance is like your application is performing properly or not, your queries, if you are using RDS and planning to migrate your RDS to Graviton, is like what are the queries that you are having, will that work properly on Graviton? So all this kind of testing you'll have to do. And once you are happy with the testing, you can do the change, and change is very easy. Okay. Similarly, for other managed services like EMR, again, managed services, and it is very easy to migrate to Graviton. Same for Lambda. Now it comes to your own application which you are hosting in EC2 instances. For example, Java application. So any applications which is interpreted based language or bytecode compiled language like Java or Python. So it is like there is no code change as such when you want to migrate from x86 to Graviton. There is no code change required, but you will have to reinstall your runtimes. Right, so you need to change the runtimes. You can keep the same version if it is supported on ARM or Graviton, but there is no code change required unless you are using some libraries which is bypassing your runtime and directly accessing the underlying operating system or resources from underlying operating system. For example, in Java, you have something called JNI. Right, so JNIs generally are written in C or C++ and then compiled and then being used by the Java or your application code. So if you have dependencies like that, then that has to be recompiled and then migrated to Graviton. Otherwise, any other Java, Python, PHP, Node.js code that you have, it can just be lifted and shifted to Graviton, and it will just work fine. For compiled languages like C, C++, Go, Rust, it has to be recompiled when you move to Graviton. Again, when I say recompile, it's the same process that you'll have to use when you are running your code on x86, but you'll have to repeat that process of compilation. And this time you'll have to compile on a Graviton server. Once you compile, you should be able to use that binary that comes out of compilation process on Graviton. And then during the compilation, all these compiler, all the popular like C, C++, Go, Rust, all these compilers has very good support for ARM64 architecture. So you should not have any problem compiling your application for ARM64 architecture. Okay. .NET. So the newer version of .NET 5 N plus, actually .NET Core 3.1 N plus is multi-platform and can run on Linux as well. And it supports ARM64 architecture. So those can be migrated easily to Graviton. But if you are using older version of .NET like .NET Framework, then that's where you'll have to first port it to higher version of .NET like .NET Core and then migrate to Graviton. Okay, so that's where you'll have to put some extra effort in order to migrate that to Graviton. And then Windows as operating system is not yet supported on Graviton because Microsoft doesn't provide licensing for using Microsoft like Windows as a server operating system on ARM-based servers. Okay, so that's a quick snapshot of how much effort you will need to port your workload to Graviton. I'll talk a bit more in detail about what are the steps involved. So for example, we generally divide the migration process of your workload to Graviton into stages. Stage 1, you will have to identify or create an inventory of the software dependencies of your workload, right? You need to know what are the dependencies that you have for your workload. Dependencies will include standard libraries that you are having with your application, open source libraries, any commercial libraries that you might be using. Along with that, any monitoring, logging, or security agents that you might have for your application. All those things you will have to create an inventory. And while you are creating an inventory, again, be aware of this native and platform-specific code. Native code, basically things like some libraries written in low-level languages like C or C++ will have to be recompiled before you migrate your application to Graviton. And then if you have some platform-specific code, like codes written or some libraries written in assembly languages, then those has to be, you will have to change your code basically, if you have assemblies. But the good thing is that you don't really find such a dependencies these days very commonly. There are very rare scenario where you will have. And even if you have, and it is provided by open source community, then there is a good chance that those has been ported already. You just have to find those ports and use those in your code directly, and you should be fine. In case if you are developing something which is written in native languages or in platform-specific code, then your application team will be able to need to port that to Graviton specifically. Okay. So once you are aware or once you have the inventory with you, you know what are the dependencies are, then the next step is to identify the ARM64 support for each of that. Okay, so for each dependency, identify ARM64 support. Like at this point of time, software ecosystem is like getting matured around ARM64, and more and more softwares are supported. Like most of the supported at this point of time are supported on ARM64 architecture. So there is a good chance that majority of the component or all of the component of your application will be supported on Graviton by default. In case if you have any problem identifying if a specific component is supported on Graviton or not, there are resources that is available for you where you can get help. So some of the resources have listed here, like one is the tool. The first one is the tool Porting Advisor for Graviton. It's a Python tool, and it is developed by AWS. It's an open source tool. It's available in GitHub. You can use this tool to point to your source code. It supports some handful of programming languages like Java, Python, C, C++, Go. So if you have applications written in this programming language, just point this tool to the source code directory of that application. It will scan all the source code and tell you what are the things or what are the dependencies which are compatible with Graviton, what are the dependencies which are not compatible with Graviton, and what are the dependencies which needs to be upgraded before you move to Graviton. So all these things this can tell you, but the only limitation is that it supports only a handful of programming languages at this point of time, right? If you have applications like Node.js application, then you will have to identify those dependencies manually and then you port your application. When you are identifying dependencies manually and trying to see if it is compatible with Graviton or not, for that there are other resources that is available. For example, we have a technical guide that is available on GitHub, which is maintained by very regularly maintained by our Graviton team. Okay, it's called Getting Started on Graviton. It's a detailed guide. It has a lot of information, things like what are the software supported. Again, it cannot have the full list of all the software that is available over there, but it has all major software that we our customers use on regular basis, and we keep updating that particular list every day. Okay, so it has a good list of software what is supported on Graviton, third-party software, as well as Amazon provided software, AWS provided software, as well as the our managed services, right? What are the managed services that supports Graviton? Along with that, it has things like if you are using a Java application and trying to migrate to Java application, what are the considerations you will have to make when you migrate that Java application to Graviton? Right? What are the changes? What are the tunings that you'll have to do? So those things are mentioned not only for Java. It has Java, Go, Python, like .NET is also there. So things like that. And there are once you have migrated your application and you are having some performance problem, this guide has a runbook that's called Performance Runbook that helps you identify or that helps you troubleshoot how do you basically troubleshoot a performance issues on Graviton servers. So it has step-by-step guides for that as well, right? So very handy tool when you are considering Graviton instances, or if you want to know more about Graviton instances, that in that case also it's a go-to guide. Okay. Then the other resources that I use very frequently is pkgs.org, where you have a filter of ARM64. So if you are looking for a software and see if that supports Graviton or ARM64 or not, you can go to pkgs, search for that software, filter with ARM64 filter, and see if a package of that particular software is available for any operating system or not. Okay, so that's give you an indication that if that particular software is supported on Graviton or not. And when I say Graviton, it is based on ARM64 instruction set, right? So it is very ARM64 compatible. Anything that runs on ARM64 can run on Graviton as well. The difference is that when you run that application on Graviton, it will give you much better performance than running anywhere else. And then it also costs you less, right? If you are talking about Docker containers, Docker Hub has, again, the similar feature where you can go to Docker Hub, search for a image, and then filter with ARM64 filter, and it will list you only those images which is supported on ARM64, and you can easily identify if the image that you are looking for is supported on ARM64 or not. Okay, so these are some of the resources. There are more, but I've just listed some like popular ones which I use very regularly. So that's the first step of migration, where you identify the inventory of the software dependency, check if it is ARM64 supported or not. Once you have that done, once you know your software is supported on ARM64, the next stage is to do a quick POC, have a Graviton server or Graviton instance created, install your runtimes, configure your application on that, and then do a quick testing of your application to see if that application works as expected or not on your Graviton servers, right? When you do the testing, we recommend to perform all the major tests that you generally do for your application, like unit test, and then any lower environment testing like UAT testing or anything else that you do. You should be performing all those testing before you migrate to Graviton. Basically before you migrate your application to Graviton instances in production. And then once you are happy with the test results, then you can change your CI/CD pipeline, change your infrastructure as code, and then do the actual deployment in production, right? So when you do the deployment, so till now, like whatever the changes that you have been doing, in POC environment, it's all manual. You are installing the applications manually, you are creating the instances manually. But when you want to deploy that into the production, you don't do changes manually, right? You have CI/CD pipeline for that. So, and that's where automation becomes key. Okay, before I go there, all the steps that I've just mentioned about how do you migrate your application to Graviton is also documented in our Getting Started guide, right? So just wanted to highlight that. sorry, if you are taking pictures. Anyway, this talk will be available on YouTube. It's getting streamed anyway, so you can take it from there as well. And as I mentioned, whatever I have talked till now, I've done a detailed talk in lspe-43. So you can, here is the link for that particular video. You can go and watch that as well. Moving ahead, so when it comes to deploy your application to production, as I mentioned, right, you don't really make any changes in production environment manually. It has it is all done via CI/CD pipelines, right? So the question comes, when you want to adopt Graviton servers or Graviton instances in your environment, does your tool or do your tool will support that? Meaning, do your tool will be able to create a artifact that can run on Graviton instances or ARM64 compatible instances, right? So does your CI/CD tool supports Graviton? And we have all the major CI/CD tool or popular CI/CD tool that is available in the market supports Graviton at this point of time, which basically means that when I say support Graviton, it essentially means that all this CI/CD tool will be able to create an artifact that can run on Graviton instances. It may or may not necessarily the tool itself can run on Graviton. Most of the time it does, but in some cases it might not be able to run directly on Graviton. But all these tools will be able to create an artifact that can run on Graviton. Okay. And that's what I meant by supporting Graviton. And most of the CI/CD tools that is being used by our customers are does support Graviton at this time. So do you guys use any CI/CD tool apart from what I have listed over here? So this is not a complete list. Sorry? Concourse, yes, that also supports Graviton. And again, as I said, this is not a complete list. Like there are tools like BuildKit, we have Azure pipelines, we have many other tools, CI/CD tools that supports Graviton. Okay. Sorry. Okay. Then when you are trying to deploy your applications on Graviton in production, the next question will come to your mind is like, can I use my existing AMI, or if you have containerized application, can I use my container images on Graviton instances or not? Okay. Any ideas? Okay. Sorry. ABIs? Sorry, I didn't get that. Native code. So when you talk images, right? Any images generally have binaries in it. And as you know, binaries are by default single architecture. Those that is changing slowly, but still, you can safely consider that even now binaries are mostly designed for or created for a specific architecture, CPU architecture. Once you have your application and if you convert that into binaries, that will basically will be only for a specific architecture, and that's true for AMI as well as container images. Okay, so and that's the reason container images or AMIs cannot be used when you change your underlying CPU architecture. So for images, AMIs basically, every AMI, if you try to describe the AMI, it will have an attribute called architecture. And this architecture is what defines if this particular image can run on Graviton or not. Okay, if it is ARM64, yes, it can run, but if it is AMD64, it cannot run. Okay. And even though the version of the operating system which is being used inside that particular AMI is exactly the same. For example, if you are using Ubuntu 22.04 on x86 and you want to use the same operating system version on Graviton, still you cannot use the same AMI. You'll have to change the AMI, right? And those AMIs are mostly available in our AWS console, which you can use and do the customization on top of that. Same, if you try to mix and match the architecture of AMI and the instance type that you are trying to run, then this is what the error you will get, which basically complains that the architecture of the AMI and the instance type that you are trying to use is not matching. Okay, this error is kind of self-explanatory. But the error that you get in case of container images is not self-explanatory. Here you will get error like this, exact format error. It's basically an generic error which indicates that you are trying to run a binary on architecture for which the binary is not built for. That's what this error generally indicates, okay? And this is not specific to container images. Even a standalone binary, if you try to run mix match the architecture and then try to run x86 binary on ARM or ARM binary on x86, you will get the same error, okay? So shifting gears slightly, I want to talk about like when you are deploying or when you are trying to adopt Graviton instances in your production environment, what deployment strategy you should be using, and or what is the recommended best practice for deploying your application on Graviton, right? So here, the best practice is to use multi-architecture strategy. As the multi-architecture strategy, basically what it says or what it says is that it basically involves deploying application across multiple target architecture or platform. At high level, the goal of multi-architecture deployment strategy is that the workload can run on multiple architecture without worrying about the underlying CPU architecture of the server that you're using, so that your application can run on those servers where you get best price performance benefit for your application, right? It's basically a way to decouple your application from the underlying CPU architecture, right? That's what the multi-architecture strategy is. And what are the benefits of using multi-architecture strategy? There are quite a few. I've just listed some. One is like you can easily transition your platform from x86 to Graviton, or from Graviton back to x86 without worrying about the instance type that you are using. The other thing is like getting compute capacity at scale. For example, let's say you have a application and then suddenly there is an event where you for your application and you need thousands of instances for that particular application in few days, right? If you just depend on single instance type, you might not be able to get that capacity. But if your application is supporting multiple architecture and you can get if your application can run on x86 as well as Graviton, then it will be easy for you to get the capacity that you need in a short span of time, right? So that's where it helps. Cost optimization, of course, as I said, Graviton instances cost you 20% less in general in all other regions except India regions, which is Mumbai and Hyderabad. In Mumbai and Hyderabad, you get 50%, it costs 50% less as compared to other x86 instances, okay? And then it avoids vendor lock-in. Basically, what it means is that once you have migrated to x86, once you have migrated to Graviton at this point of time, because it provides better performance and price at this point of time, in future, if other vendor, for example, Intel or AMD provides better performance, and then you want to come back to x86 architecture, then at that time, if you are adopting multi-architecture deployment strategy, then at that time you will not have to rework and then do all the assessment and then migrate back your application to x86, right? If your application is multi-architecture, you will be able to switch between x86 and Graviton seamlessly, right? So that's another advantage of using multi-architecture deployment strategy. Okay. Now, when you are trying to adopt Graviton in your production environment, what are the changes you'll have to make in your CI/CD pipeline so that it can create artifacts that is compatible with ARM64 or Graviton servers, right? So for CI/CD pipeline, there are three major categories for which you create CI/CD pipeline. One is for creating AMIs. Okay. Another one is for creating application artifacts. And then one more is for creating container images if your application is containerized. Okay. Like, do you have CI/CD pipeline for anything else? Generally in terms of compute. right? Deploying your softwares and things like that, right? These are the three major categories that I've seen. And with these major categories, like I'll talk about all these three categories and what are the changes that you will have to make in your CI/CD pipeline to ensure that it can create artifacts which can be deployed on ARM64 servers or Graviton servers. So a generic CI/CD pipeline for AMIs, creating golden AMIs for your application or in your environment might look like this, where you have a code repository and you have your AMIs AMIs baked into it. And then if there is any changes, then there will be a CI/CD pipeline which will be listening to any changes in that code. And once it detects any change, it will launch a EC2 instance. It will do the customization on top of it. When I say customization, it will do things like hardening, installing your runtimes, and then installing things like security agents, monitoring agents, logging agents, things like that. Okay. So all this customization you perform, and then once you have done with the customization, you create a golden AMI and then distribute to other AWS accounts in your organization or other AWS regions, right? Or you basically register it to a central kind of repository from where other team in your organization can refer to and use that AMI, right? In this, so the major changes that you'll have to do when you try to adopt Graviton instances is the first two stages, launching the instances. So what you'll have to ensure is that the build script or the build script basically which is executing all these stages should be intelligent enough to understand what is the architecture of the AMI, and based on the architecture of the AMI, select a correct instance type so that it can launch the instance and run the instance properly. So that's what the change that you'll have to make in the stage one. In the second stage, like for the hardening, most of the time, if the operating system is same, you don't really have to worry about the hardening because most of the time it will work fine. During the application installation, especially when you are trying to install a third-party application, without using system things like yum or apt, then you'll have to make your build script intelligent enough to understand on which architecture, underlying CPU architecture it is running, and then pull the correct binary from the repository and then install the correct binary. Otherwise, you will get that exact format error, and then your installation will not succeed basically, right? So that intelligence you'll have to build in your build script. So these are the two changes that you'll have to do in this stage. And once you make these changes and then create a parallel pipeline, then this pipeline will be able to create two images every time you make changes in your image, or every time there is a OS patch that has to be applied, or any change that you are making in your runtimes, or in things like security agents or monitoring agents and things like that. Then it will be able to create two images for you, which you can use either like Graviton or ARM image you will be able to use on Graviton instances, or x86 image you will be able to use on Intel as well as AMD instances. Okay.
So one question. I really forgot.
Sorry.
What the GCC flags are. So if we run GCC, so it generally by default, if we run on Linux machine, it creates a header flag.
Yeah.
Is there a flag in GCC which can build a non-ELF binary sitting on a Linux?
Yeah, I'll talk about that. So general recommendation is when you are building or working, like if you are a developer and you have a x86 laptop, and then you are trying to build a application which will run on x86, that's where knowing the flags becomes handy. And because you want to do a quick compilation and see if your application is working as expected or not, and if there is any problem, come back to your editor, make changes, and then do it again. So at that time, you don't want any delay, right? But in your production environment, because this kind of emulated binary building or emulated compilation or cross compilation can create a lot of performance issues, we do not recommend you to do that in your CI/CD pipeline. When you are doing it in your CI/CD pipeline, ensure you are using a server for which you are building the binary. For x86, launch a x86 server and build your binary on top of that. For ARM, use a Graviton server and build your binary on top of that. And when you are building those binaries on native architecture, you don't really have to worry about the flags, because the operating system and the default configuration in the operating system will take care of that automatically. Okay. So that's about AMI, and this is what the change you will have to make in the AMI. Let's talk about application artifact. What are the changes you will have to make in the application artifact? So in the application artifact, as I mentioned, right, if it is a interpreted or bytecode compiled language, you don't really have to make any changes in your application. The same application code, just lift and shift from x86 to Graviton and it will work fine. If there is any native code or native dependencies, then those has to be recompiled before you move that specific piece of the code to Graviton. Okay, there is an example that I have provided. I will not go in detail over here. In some cases, there might be a dependencies of that you are using. The exact version of that might not be compatible as it is, but if you upgrade to the latest version of that specific dependencies, it will be compatible, right? So in that case, you just have to upgrade and no need to kind of recompile that binary as such, right? So this particular scenario we are seeing more and more these days as software ecosystem is maturing around ARM64. Okay. Then again, if you have compiled languages, you will have to recompile, as I mentioned. In application pipeline, so the first stage, code building, depending upon your application, if it is Java, you don't have to make any change, and you don't need two different stages over here. Just one stage will work fine. But if you have a C or C++ application, then you need two different stages over here as well. In the test environment is where we recommend you to always have two different test environment, one for x86, one for Graviton, and ensure all your test case that you run for x86 also runs on Graviton, and the test passes. And if in case some of your test is not supporting multi-architecture environment, then rewrite those test cases, right? So that's what the recommendation is. Always test in both the native environment and deploy that to production only when all the test passes in both the environment. Yeah. Yes.
Graviton is basically ARM, right?
Graviton is not ARM. It's basically using ARM instruction set, CPU instruction set.
Sorry, so like there, like Nix is a package manager, right? So both cross compile. Like I'm on x86, it can cross compile for ARM. So does it have that support on Nix or those OS?
So I'm not very clear on the question. So cross compilation is the function of your compilers, right? It has nothing to do with the servers as such or operating system as such. The compilers, different compilers, for example, C, C++ compiler, if you use to compile your application, it does support cross compilation and you can use that. Yeah, I'll talk about when to use what in a few minutes. Quickly talking about container images. So in container images as well, container images will have two things. One is the OS image, base OS image as well as your application. So what are the things that you have seen in the application part will apply over here as well, along with the container images, right? So build and push. So build your application, all the things will be same over here. If it is Java application, there is no extra effort to build your application. But if it is C or C++ or Go, you will have to recompile your application. So that you'll have to keep in mind, and then build your image, right? When again, the images are architecture specific, so you'll have to build two different images. One is for x86, one is for Graviton, and then push both into your container repository. Okay. Now, one good thing with images is that container images now supports a concept called multi-architecture image. So multi-architecture image is basically combination of multiple images into a single image. So it's basically a manifest that you create on top of multiple images, and then wherever you want to use those images, instead of the individual image name, use the manifest name. And if you use the manifest name, the container runtime will automatically understand that you are trying to use a multi-architecture image. And when you are trying to create a container out of that multi-architecture image, container runtime will automatically check on which CPU architecture it is currently running, and it will pull only that specific image from the repository and use that to create container images, right? So that's a functionality, additional convenience that is being provided by you by the container images, which you can use.
Is there any speed up in build?
Sorry?
By using Graviton. Is there any speed up on build time?
Like image build time or application build time? Yes, it is. It is depending upon what kind of application you are using, but in most cases, yes.
Related question: do you mean that if we are using a 4-core Intel, you need a 4-core AX+1 Graviton to get higher performance?
So the question is like, if we are using a 4-core x86, do you need a 4-core Graviton instance in order to get better performance? Now, better performance is a subjective thing, right? So it could mean a lot of things. The general recommendation is that you start with the same core server. Keep an eye on the metrics, business metrics for your application. For example, latency, for example, throughput, for example, concurrency of your users. Keep an eye on all this and see how much it is able to handle. And if you see that Graviton is able to handle, the same level of traffic with low CPU utilization, you might want to resize that instance. And instead of using 4 vCPU, use 3 vCPUs, right? And see if, so that's an exercise that you will have to do.
At least from my understanding, I have seen the benchmark. ARM needs some extra CPU from the public space.
Yeah, Graviton is not that way. As I was showing you slides initially, Graviton has got special tweaks and designs into it, due to which it works. It performs much better for cloud workloads. Like all the workloads that it can run in cloud, most of them performs better on Graviton instances. When you compare like to like x86 to Graviton. Yeah, sure. Not really. So here it's a multi-architecture image that you are trying to create, right? So here, each stage will create one image. Here, this will create a x86 image and push it to the repository. Here, it will create a ARM image, ARM64 image, and push it to the repository. Once you have pushed the repository, in your repository, you have 2 different images. So every time you want to deploy your application to any server, your build script should know what image to pull depending upon on what server you are trying to deploy. Either it is x86 or Graviton, right? To help you reduce that pain, there is a concept of multi-architecture container image that you can create. Then in your build script, you don't have to care what kind of image being deployed. You can just take the image and deploy it to any server. It will just work fine. And
Whatever way you identify the image.
Correct.
So basically, there will be 2 images.
Correct. No, not really. That's what
he's saying for multi-arc. Multi-arc is a composite image which has 2 blocks with a manifest pointing to each block with a different. The way container runtime will invoke the part of that image depends on where it starts.
So
images are built to layers.
Correct.
Different layers we have. So that's where I was thinking, why not only one image can have a layer into it, while pulling it, my Docker environment, whatever.
So that's rewrite of the container engine. So that I think that's
not really. Like, do you know like what kind of information your images has? Mostly binaries, right? Some codes as well, but mostly binaries. And all the layers that you're.
His call is.
No, I understood his question. I'm just trying to explain why that is not very easy, right? Because most of the time your images will have binaries, and it will be very difficult for you to know where the binary is and where the application codes are, right? And when you try to mismatch the binary and its architecture for which it is built for, it is not going to run, and that's why it is not easy for you to use same image layer in multiple different CPU architecture. It becomes difficult, right? If you
we'll come back there later. I got it.
Yeah.
Usually in the Artifactory, when you do the push with this multi-arc image, there will be like one x86, one ARM, and then one manifest. So if you're doing a Docker pull on an ARM machine, then the manifest will say to pull the ARM image.
Correct.
So totally 3 uploads will happen. One is an Intel x86 one comes here and one. The other is a manifest.
So my thought was, why not building it, right? Let's get built to different layers. So while building, I will be building with 2 layers. One for x86 for
It actually requires 2 hosts to build that image. Okay. So it runs parallelly and then pushes it. It's not like one host which is developing both x86 and the Graviton.
I understood his query. See, if you are, for example, if you are using single image, let's say one layer of the single one image on both the images, right? One layer will have some binary on it, and as you know, binary is compiled for only one architecture. When you pull that layer and execute, if it is built for x86, if you pull that layer and run it on ARM, it will throw an error saying
We'll take it like offline.
automatically it cannot change, right? You'll have to create a layer for that, right?
So if you find a hack to make it work, the image size will grow unnecessarily.
But in that case, it will also install, like say for example, you have one image and you deploy it on your server. By the time it will pull artifacts for the another image. Which is
Let's
not
park it.
deployed.
Let's park it.
Park it for out.
Let's
Yeah.
park
Let's
it.
park.
Offline. Take it.
This is a different question, which is the nature of LSP meetups.
Yeah, I just wanted to show you like what are the commands that you will be using. So this is at a high level, either top one or the bottom one, both does the same thing. The bottom one is more developer friendly. And although you see a lot of commands over here, actually, this is the command that you should be using all the time. These are all one-time commands that you need to set up. Once you do this using buildx, these are all one-time command which you set up. Then this is the command that you should be using every time to create a new image, and it will automatically create a multi-architecture image for you. Okay, but this is a more native way of building it using manifest directly. So every time you want to create a multi-architecture image, you will have to run all these. Actually, not 4 commands, 6 commands. I have not used pushed over here, right? I'm not pushing it. So yeah, individual images, I'm not pushing it. You will have to push the individual images as well. So 4 + 2, 6 commands you will have to use every time. But it might not be very friendly for your developer environment for day-to-day work, but that is what is recommended for CI/CD pipelines, because once you script, you don't have to rewrite it again. And the benefit over here is that it uses native build. Now, the question that has, sorry, not here. Let me go back to my slides. Here, I was here. So the next question that I have been getting is, like multiple people has asked is, there are different ways of compiling application. Why should I use one specific over the other? So there is a native way where native way basically way of compiling application basically means that you compile your application on the architecture for which you are building your application. Emulated, you know emulation, right? QEMU. You use QEMU and create artifact of any architecture on any machine, right? So that's emulation. And then there is a new thing called cross-compiled, where you are running on x86. If your compiler supports ARM64 cross-compilation, you can directly create an artifact of your application from x86 for ARM or Graviton target server, right? So these are 3 different approaches. I'll tell you the problem with emulated is that emulation, as you know, it's very slow. It takes a lot of time. If you are okay with slowness, you might want to opt that. But another problem with emulation is that, you know, emulation, as you know, it basically mimics the underlying CPU instructions, right? So there might be a situation where some of the, although it is open source and people are updating it very frequently, there can be a situation where some of the instructions that has been come in newer version of ARM64 is not updated over here. And your application is using that instruction, and if it is not able to find here, then either that application will not work, or it might have some performance issues, right? Which you will don't know, because your application is designed to perform, you know, in optimal manner. So debugging those kind of problems becomes very difficult when you use emulated build. So that's why it is okay to use in your dev and test environment, but don't use that in production. When you are trying to deploy your application in production, don't use emulated builds. Recommendation is to use native builds. Now, why not cross-compile? So the problem with cross-compile is that although the feature says that your compiler supports building a different architecture image on a different architecture machine, right? But the problem will come is that, for example, I'll take an example. Let's say you are trying to build a curl binary. Okay, so as soon as you start building the curl binary, you will soon realize that curl depends on a lot of other packages. For example, OpenSSL, zlib, right? There are so many other dependencies on which it depends on. When I say binary, it depends on it. What I mean is that the ARM64 binary. So on the x86 system where you are trying to build a cross-compiled binary, there OpenSSL will already be there, but it will be for x86. It will not. Your cross-compiler will not accept that. It will ask you to have a ARM64 build of OpenSSL and then build your curl. So it's basically going into chain of your dependencies build. So before you build curl, you will have to build OpenSSL. And again, not to say OpenSSL will depend on 10 other dependencies. You'll have to build all of them on your system. And then same goes for zlib. So the problem with cross compilation is that it is a heavy lift when you start. Once you start, because your application is constant, I mean, just you're changing some minor things on that. Once you have built all these dependencies, next time if you build, it will be very quick for you. You don't have to create a new machine. But when you are getting started, you will have to do this heavy lift. And that's where the problem is. If you can manage with that heavy lift, cross-compile will work for you. Otherwise, stick with native. Native, create an instance, do the compilation, and you're okay. Right?
Sorry to stop you. So to just make some performance improvement and some savings, this is actually taking a layer of complexity into multiple layers now, right? So now one binary, I have to maintain it in two different, and then have build a process, emulation, test cases, and all this, because I need to verify in both the things. Is it really worth to have one application in both the
that's a call you will have to take as a business owner for your application. We are providing you guidance, like what are the benefits you will get out of maintaining these two different version of application. You can, so Graviton or x86 provides you benefit of performance, benefit of cost savings for your application. And if you want to use Graviton, you can either opt to just go migrate your entire application to Graviton and don't worry about x86 anymore. But again, as you know, over the last couple of decades, x86 has been dominating the server market. And you have not seen really any competitor as such for x86. But now there is ARM is there, and it is real thing, right? So now, as the earlier time before x86, where you had a lot of different power PCs and things like that, where multiple architecture were there, now also that time is coming again, where you will have to consider multiple architecture and know where your application, where you will get best price performance for your application on which architecture, and then use that accordingly. Now, as I mentioned, right, the benefit is that today Graviton is providing you best price performance, and you want to use that. Tomorrow, if Intel comes with better price performance of their servers, you will, if your application is not multi-architecture, you will be losing that, right? You will have to again incur the cost of migrating back from Graviton or ARM to x86. Right, so you will have to do some extra work to maintain two different versions of application, but these are the benefits that you are getting. So you will have to do the analysis and see if the effort that you are putting it.
What is the
really
percentage
worth.
of savings we are talking about?
So at least 20%. If you are deploying
20% on the CPU.
Sorry.
20% on the CPU
cost. The EC2 instance cost that you are paying right now, at least you will be saving 20%. If it is in Mumbai or Hyderabad region, 50%.
It's kind of a cascading cost change. Mainly cost is the factor, but if I am a company and I'm taking care of a lot of things, I have a pressure of giving low cost because of competition to customers. But to maintain an infrastructure, say build system, backed by Kubernetes, if I'm having 200 nodes, I'm paying with Intel. If I change it with ARM, my cost also reduces, so I can give more benefit.
Yeah, and I'll correct him. It's not just about cost, it is also about performance. So there are a lot of examples available where database has been run on Graviton instances and the latency has improved very significantly, at least 20 to 30% latency.
I'm a little bit skeptic about having multiple versions of the images, and then you never know, right? One day you want to get out of it, you're stuck because some things may not work back in x86. You would have been tested or something. We can take it offline, but what I'm telling is the effort should be at least 40-50%. Then it makes much more sense to if you are a large scale environment. If you are a small scale and small things.
What you're saying is very correct. Most of our customers which I talk to has similar kind of problems or similar kind of thought process where they really think, should I be going in that direction or not? And it all boils down to what really you want from your application, right? If you don't have enough resources to invest into both of these, you can just migrate to Graviton, and that will also work fine, right? There is no problem. This is the best practice that I talk to you about. This is what we recommend you, but nobody is stopping you to just use Graviton or ARM64 architecture. Okay. Like I have a quick demo that I want to show you, like what are the changes that you'll have to make just to give you some idea. But before that, this is the last slide that I want to talk on technical guide. All the information that I talked about, almost all of them are there in this GitHub guide. And again, it's a GitHub guide. If you have any questions that you want to ask to a Graviton team, you can open an issue and we'll be happy to answer any questions over there as well. Okay, and now talking about my demo. So in the demo, I have this application that is already set up. As I mentioned, right? Like any bytecode compiled languages can be migrated easily to Graviton. There are a lot of examples of Python, Java available already on internet, how to migrate that to Graviton. I've taken a .NET application for which not a lot of examples are available in internet. So I'm just trying to show you the overall process of migration will be exactly the same. There will not be any difference. So here I already have a environment set up where x86 version of the application is running. I'll quickly show you what are the changes I've done in my Jenkins CI/CD pipeline to create a multi-architecture image and then deploy that to Graviton instances. Okay, so for that, let me end the slideshow and go to my terminal. Sorry. So just, is it visible?
Yeah, is it Cloud9 share or what?
Yeah. So so this is the Jenkins file that I am having. This is x86 specific Jenkins file. And then so this is x86 and this is what is being running in my CI/CD pipeline right now. This is the multi-architecture version of the Jenkins file. I'll show you a quick diff of these two. Compare selected, and let me close this. Not very pretty actually. Sorry. Yeah. So if you see most of whatever the stages that I had in x86, it's there in multi-architecture as well. So the first part, it is the multi-architecture thing. And then the second one is x86. Let me reverse that actually, that will be better. So let me select x86 and Jenkins file and then compare, hopefully. Yeah. And close this. So here I have multiple stages. The first one is to, I'm creating a worker, basically Jenkins worker, where all my compilation will be done. So when I'm creating the worker, I'll have to ensure my Docker is installed so that it can create the Docker image. Since I'm using .NET application, .NET has to be installed. So all these prerequisites I'm doing in this stage. So this stage is specific for that in the Docker agent. And it is common since in x86 I didn't had any ARM environment, so I'm not doing anything for ARM over here. But in this stage, I've created a separate stage just to do this prerequisite check for ARM. So this is the additional thing that I've done. Then next is I'm doing the compilation. So here I'm doing single image compilation. Here, if you take a look at the Docker build, here platform is just Linux AMD64. Over here, I'm using Linux AMD64 as well as ARM64. So I'm building my container image for both the environments. Again, I could have used Docker manifest create as well, but I'm using that's very straightforward, and examples are available for that very easily on the internet. But multi-architecture build with BuildX with native build is not available very easily on the internet. So I have just wanted to, show you that that is also something possible. So Docker BuildX by default, it comes by default with your Docker desktop. And when you try to use multi-architecture build, multi-architecture image with Docker desktop, by default, it uses emulated build. Okay. So in order to use native build, you will have to do certain configuration. And in that configuration, it basically means you'll have to create a ARM64 server or Graviton server, pass the information to Docker BuildX, and then let Docker BuildX know that this is the server available for you to create multi-architecture image. And once you have defined that, then Docker BuildX will automatically use that server to create multi-architecture image and then push that to whatever container repository you have, right? So that configuration is not, I didn't find online very easily. So I created an example for you. All this is available in my GitHub repo. I'll share a link as well for you. And then the last one is doing the testing. So as I mentioned, right, every test case that you are having in your x86 environment should be supporting multiple architecture if you are building multi-architecture environment. And then if your test is not supporting multi-architecture environment, rewrite that test case. And that's what I'm doing over here. Okay. And then, yeah, so these are all the changes I had to do. And the deployment, in this deployment, basically, I'm doing a, so I'm Node Affinity, basically, I'm deploying, since my image is x86 specific, I'm deploying on x86 instance only. But in case of multiple multi-architecture image, I don't really have to worry about where it gets deployed because it can work on both the environments. And my EKS cluster contains both the environment, like both the instances, x86 as well as Graviton. It will deploy on both and it will work just fine. Okay. And so these are the changes that I have made in the CI/CD pipeline. And this is the application that I have over here. Right, it is currently running on x86. Hopefully it is visible. So here the application architecture, as you see, is x86 over here. Now, if I go to my pipeline, okay, where is my password here? Yeah, if I go to my pipeline, changes, sorry, not change, configure. And then I just changed my build script. So the multi-architecture build script name is Jenkins file instead of x86. So I'll just remove that, save it, and do a build. So once I do a build, it will start building, and it will build the multi-architecture image for me, push that into my ACR repository, and then deploy that on my EKS server. Okay, so all these things it will do. The main motive of showing you this was that although it might look like there is a lot of work that you will have to do when maintaining multiple version of application, but in reality, it's not that much. It's just a mindset change. There are two main things that you'll have to be aware of. One is mindset change of the developer. Developers should be aware that whatever code that they are writing will be running on multiple environments. And once they make sure that their code runs on both the environment, you don't really have to worry about code failures that is happening in CI/CD pipeline. Again, CI/CD pipeline also, you will ensure that you are checking or testing your code on both the environments, and if there is any problem, that will get detected and get fixed over there, right? Although initially it might seem like there is a lot of work, but once you adapt this process, it is not really of that much work that it may look like from now. Okay. So it will basically do the deployment and deploy it over here. There is no change in the application that I'm making. So application will be exactly the same, but you will see once the deployment is done, you will see that the instance type has changed over here, and it will be deployed to the Graviton instances. Okay, it will be done in few minutes. But while it is doing, if there is any questions that I can take, I'll be happy to take.
Santosh, how is the benchmarking on these cross-compiled applications?
Cross-compile application, I have not seen any performance difference as such, like because the compiler itself claims the support, like full support of different architecture. And like I have not seen a lot of customers using cross compilation, but there are few customers who have used it, and I have not seen any report of performance issues as such, and I do not expect as well. So if you can work with all the dependency mess that you have to deal with, then cross compilation should work for you.
Basically, it means you have to take care of the development is more, because if it's working in ARM, you'll get some set of works. Even at compiler level, right? The way it interacts with memory or is different, right?
Yeah.
And how it works in x86 is completely different.
Right.
Now you have to handle both of them, right? Now because see, in our
you see, the problem is like when you talk about things like Java, you don't really have to worry about, because all your runtimes are taking care of it. For example, Python, Node.js, these kind of high-level languages, you don't really worry too much about the low-level things that you're talking about, memory management and things like that.
Coming at JVM itself, they themselves have works at JVM level,
Correct.
Platform level.
Correct.
Like latest ones, right? Like when Kubernetes upgraded, the C groups changed, and a lot of things broke apart. So a lot of things happen at that platform level.
Correct.
Now there are more problems to take care when you have two platforms.
Yes. Yes.
So now I think basically building is one thing. And the maintenance is also becomes operational, also becomes costlier, and development cost also will be higher if you're going this way.
Correct. Right? But the benefit that you get out of it is like, today you need 10,000 instances of your for your application to handle some event. Then in that case, if your application is multi-architecture, you can easily get the capacity that you need. So there is a cost involved everywhere, right?
Your
So
monthly
you have
bill
to-
will come down. But the end result is same.
So this is like,
Yeah.
okay, let's finish this.
And like I just want to re-emphasize again that it's a best practice, but it's not something mandatory for you. If you don't want to do multi-architecture, that is also fine. A lot of customers who has adopted Graviton are not doing multi-architecture. It doesn't mean they are not successful in adapting Graviton instances. They are successful. They are working with. They are very happy with the price performance that they are getting with Graviton servers.
Question is not that. Question is the 20% savings what they get.
Mhm.
They might decide not even go to Graviton. From business point of view, right?
Correct. Correct.
So because there is cost, operation and development cost involved, which is recurring, and of course there is performance and
No. So I don't agree with the recurring development cost, because today you're developing for x86, right? So any problem that can come on x86, that problem is already there, right? So if you are developing for ARM, similar you will have to deal with the similar kind of problem there as well, and it's same. There is no difference over there. The difference will come when you are trying to maintain both. Then you'll have to deal with the both the problems, and then you are getting benefits as well over there. So it's a trade-off that you'll have to make.
that you're talking from developer who is writing a Java program or Go program.
Correct. Correct.
So write a real platform program like C, for example, right?
Yes.
Right, or Rust, for example. Right?
Correct.
So these guys will have to take care of it. They have to be a little more careful on that. But the question is not the thing is from business point of view, you have to do it right. So there is cost involved there, like operations development. There is one. But they just put in paper there, right? And 20%, let's say 30% savings what we get overall. From the easy cost is what you're saying. There are other costs that are involved that will still be there, right? Now if you take that, of course, people who want to go ARM and they can go only for ARM, benefits of ARM, they can go to Graviton. No issue. What is it very attractive from Graviton, which I can say that for these guys who are thinking this way, that cost is very high, operation is very high, and like operations and take care of all this. Difficult for me being a mid-sized company. AWS has any plans for making these things easier, like a development toolkit or something like that?
So development toolkit. I mean, what kind of development toolkit do you need, which will make your life easy?
Very simple. For example, right, if I had to run my application for say for example, I want to run a web server. Right? Today, if I had to write a web server on my C and I want to take care of operations on like operation and development, what are people do right today? They use your standard libraries which are available, right? Not everything is available for ARM. Very few people.
Yeah, but the question is like, how many people in the industries are writing their own web servers?
least give an example of what people.
No, so like AWS can see here. AWS as a company is as you might have heard, we are very customer obsessed, right? If we get a signal from the customer that you require some tool which needs help in developing your application on ARM64 architecture, please let us know, and we'll give that feedback, and then we'll have some tool kind of build in. Yes, compatibility checker is already there now. We have a tool called porting advisors for Graviton. Yes, it's there. It's an open source tool.
I mean, these tools which will help them saying that, can we rerun this and see how well might recompile? Just giving a score saying that this will work this best in Graviton. Something like that.
Yeah, see the problem. What you are trying to, I understand what what you are trying to say, but the problem area, if you really analyze that and see, it's not something very small. It's really broad at this point of time, and not a lot of customers are looking for this at this point of time. If we see a signal like that, we'll definitely do something in that space.
You have a toolkit.
Yes, we do have. Not really a scorecard. It's during the planning phase when you want to migrate your application and to see if your application will really work on Graviton, or if there is any issues as such, like compatibility issues. For that, there is a tool. It's called Porting Advisor for Graviton. Yes.
ARM is still CPU, right?
Sorry.
Our Graviton is still CPU, not GPU.
It's a CPU. Yes, it is a CPU. It's a general purpose CPU like Intel processors. Yes.
So I think the trend is coming because of the having worked for data GPUs and what is it, NPU or some other architectures coming up. Right? So now we're looking for a framework where I can build for all those architecture as well, right?
So we have Trinium for that, no Trinium, and yeah, we basically have to train your AI model.
Problem scope is broader, right? Because it might be currently I will be running my workload HT environment or David environment in CPU. But for a production, I would like to go in GPU architecture. So my application has to be compatible with that.
No, I think you're getting it wrong. Like if you want a GPU, your development or your lower environment should also have a GPU. Otherwise, you will not know how things are happening in the GPU. So GPU, like you cannot mix match over there. There are certain workloads that you can run on GPU only, or certain workload you can run on CPU only. So that is there already. It's available. Sorry,
I think we are talking different things in.
We are over time, so.
Is the demo over?
Yeah, I'm done. So like just showing the last bit. Hopefully, it has deployed now. And if I just refresh, yeah, as you can see, it is running on ARM64 architecture. So
is it only the text or really?
It is really. So the source code that I have just showed you demo.
I saw a couple of echo statements.
Yeah. So the source code that I have just shared over here, the demo, it's all available in my GitHub repository. You can go and check out over there. So GitHub repository is here. This is the repo. .NET on Graviton. You can just go and check it and play around with it. And if you have any issues, please let me know by creating a issue over there, and I'll happy to help you. Okay.
Hey, thanks a lot, Satosh.
Thank you. I'll just disconnect.
Yeah. Okay. Now we will be moving towards real-time data ingestion using data flow and Cloud Run. Ojas Singh and Harshit Agarwal from ZeoTap will be talking about it. Please don't run.
Okay. Is there a split?
Hi everyone. So my name is Ojas. I'm a software engineer at Zeotap. This is Harshit Agarwal. He's a senior software engineer at Zeotap. And today we'll be talking about our recent revamp where we move towards real-time data ingestion using data flow and Cloud Run. So Zeotap is a customer data platform. And one of the major tasks for us is to collect data from multiple sources, standardize and clean data, ingest it into our system, and make it available for downstream processing. In this processing, we also do some sort of ID resolution where we merge some records into one another based on some common identifier. So on top of this, what we also have to do is provide metrics along each stage to keep our users updated about the status of their ingestion. In real-world scenarios where a website wants to display personalized offers to a client based on his cart or based on his current activity on the website, all this ingestion and segmentation and other downstream tasks that our software does have to happen very fast. The longer you wait, the more irrelevant the information becomes, as the user might already have changed his mind or already have done some other things. And the faster, the better, because it also gives us more breathing room for our downstream services, and also considering network delays. So the first step towards this is to ingest data faster into our systems. In this talk, as I said, we'll talk about how we revamped our architecture to a stream-based to reduce the time taken in this ingestion.
All right. So for what we'll do first is we'll explain how the previous architecture used to work, what are the challenges which we faced in that architecture, and then we'll run about the new architecture which we built, and that was a moving towards streaming. So in our previous architecture, we had an integration service which used to collect events from multiple sources, clickstream data from websites, data warehouses, flat files dropped by the client. This all data used to get collected. For the streaming ones, this data used to enter into PubSub topic. We had a data flow which was attached to the subscription. This was a streaming data flow. This data flow used to batch the incoming streaming data in the batches of 24 hours. This was configurable based on the requirements. Batch these data and drop a file on GCS. As soon as this file was dropped on GCS, based on consuming the file drop notification, we used to trigger a Cloud Data Fusion pipeline. What Cloud Data Fusion pipeline internally used to do is spin up an ephemeral data proc cluster. Inside the cluster, we used to do the transformations and cleansing of the data, the standardizing of the data, and then ingesting it into our Cassandra, our DB, which we used to use Scilla DB for our use cases. And this was the first part of the ingestion where, so basically our entire pipeline is divided into two parts. This is the first part where the data gets ingested into our columnar storage. The second part is we wanted to reconcile this data as well. So for resolution and reconciliation of this data, we had an ETL pipeline. We used to run it in a batchly manner of every that was also configurable, so a frequency of between 4 hours to 3 hours, depending on SLAs. And the ETL pipeline that used to only read this data from Scilla using a data proc cluster and then write it into individual stores in BigQuery. The BigQuery was where the downstream services can consume this data for their segmentation and activation use cases. Exactly. All right, a little bit more into the Cloud Data Fusion pipeline, which we are running. So this pipeline is simple. ETL, where we pick up data from the file, we read that file, we cleanse the data, we standardize their columns against our internal catalog of standard columns, and then we ingest this data into Scilla. So there was one major requirement which we had was to also give out information about the errors, collect the errors, and share this information with the client as to what is happening with their data in their entire pipeline journey. So we were able to do this for the transformation stage because the CDF internally provided those error collectors for us. So, but when when the errors came in the sync side, where we were adding sync directives to write this data into Scilla, if there was an error there, this error was not emitted by CDF, and there were difficulties facing collecting that and conveying it back to the user. Also, there were certain cases where, let's say, 90% of your file has been processed. 10% in 10% of the records, there is an error where we are not able to ingest data into Scilla. The entire CDF pipeline would fail. This could cause the reprocessing of the entire data because of the batchly fashion in which this was running. All right. So couple of difficulties which we were facing because of our previous architecture was, first of all, the entire thing was sort of a batch leaf manner. SLAs were kind of high. We had a requirement to reduce the SLA. Then when the scale increased, this worked for us in the beginning, but as soon as the scale increased, we started facing issues with long running pipelines. We were not aware, sometimes the cluster would not even trigger, since the tracking of the CDF pipelines was done via the callback setup within the CDF itself. So if in cases where the CDF data per cluster got killed almost immediately, we would not even know what was the status of the pipeline. And because of the sequential manner in which these files used to get processed, the rest of the files would also get stuck in the stage, the entire pipeline. So based on certain these problems and challenges which we were facing, we figured out how to move away from our batch fashion into an event streaming architecture. We'll just run through that as well. We'll just back to you. Yeah. So as you mentioned, we have a service which used to capture events from all the different sources. And it used to earlier batch that data into a file which was processed via the CDF. What we decided to do was to directly stream those events to our ingestion service instead of batching it. For this, what we needed was a highly concurrent processing system which can auto scale. So in effect, what we actually wanted to do was capture events from multiple sources, push them into our service for ingestion, and then later ingest them into our OLAP database. And all this we had to do without moving the data out of the client's project because of our no shared architecture. For this, as I mentioned, what we needed was a highly concurrent processing system, and it had to be separate for every client because we did not want to manage the overhead of managing processing system for every client in every project. Given our system is a native GCP, Cloud Run fitted well into the solution. And so what our ingestion integration service, which collected all the events from multiple sources, it collected the events and passed it in form as a stream into a PubSub. After enriching it metadata like which source it is captured from, which client it is, what time it is captured on, etc. Once it is pushed into the PubSub queue, we had our service, which was earlier deployed as the sync plugin in CDF. We had that service deployed to our Cloud Run instance, and that PubSub used to stream those events directly into the Cloud Run. Other than that, the PubSub also had a data flow attached to it, which used to batch all these events in order into files. And this was done just to make sure that if we ever wanted to reprocess these files, we can do that. On receiving the events, the Cloud Run again cleansed it, standardized it, and did all the processing. The ID resolution part was also done by Cloud Run, where it merged records based on some common identifiers. And once that is done, it used to ingest the data into the Scylla database. Now, any errors in PubSub or PubSub were retried. And in Cloud Run also, we had configured our errors. We have configured our error into broad categories like data-related errors, non-data related errors, and we had separate handling for that. For example, any data-related errors were directly pushed into a PubSub queue, which used to write it to a dedicated BigQuery table. Now, the reason for doing that was, as Harshit mentioned, if 90% of the file is completed successfully and the 10% failed due to some records which were errored, those records only will be pushed to the dedicated BigQuery table, and later they can be reprocessed and retried. This reduced our overhead of reprocessing the entire file. PubSub dynamically adjusts the rate of push requests based on the rate at which it receives the success acknowledgements. And in case it received too many negative acknowledgements, it can also add a pushback of and adjust its rate of delivery and all. So that helped us when we had sporadic increase in loads and we wanted to process at a higher QPS. We also had the use case of ingesting batch data. In case any client dropped a flat file or some sort of batch data into a system, what we used to do was we used to break that batch file into a stream of records using a data flow. And then we used to process those stream of records in a way similar to the streaming architecture.
as I mentioned, to serve our analytical use case like count calculation, segmentation, or activation of users, the data needs to be present in the OLAP store. We use Google BigQuery. And by going by the traditional batch ETL, it took more than 5 hours to process one batch of data that was ingested by CDF. In order to make that scalable, in order to make that incremental, what we did was we attached the PubSub queue from Cloud Run to BigQuery, and we used to stream all those standardized records from Cloud Run to the BigQuery table. And the issue we faced there was our data in the BigQuery table was written into separate stores because of the nature of data. For example, some events were written to a different table, some were written to a different table. That was all dependent on the type of data that we were receiving. So the issue with PubSub subscription is that if you configure it with the schema, then in order to change that schema, you have to delete the subscription and recreate it. Schema change was quite frequent in our use case. So what we did was we used to write all these records as a JSON in a dedicated BigQuery table and perform merge queries to load the incremental tables. What this helped us to do was all the data in our individual stores was loaded incrementally, and there was a dedupe in place because we used to join based on an identifier which was added during the Cloud Run stage. We also wrote a recursive CTE to perform the reconciliation of data, as I mentioned, based on some common records. So the limitation over there was we can only go to a certain depth in the recursive CTE because it's very heavy. And that did introduce some around 5% of errors into the reconciliation. But the main idea behind incremental ETL is to process small amount of data in small batches with a slight margin of error that will be corrected over time as the system progresses. We also run a full batch ETL after a week. It's weekly or fortnightly. That depends on, again, the SLAs and the use cases. But it can definitely be configured. So as I mentioned, all our data that is written into Cloud Run is directly streamed into BigQuery in real time. So that data is still available there in real time. And we can micro batch it and process it into individual stores as per the cost and SLA that we want. Also, once the data is written into individual stores, to give it to the downstream, we used to earlier create a full joint table. Now, as the size of data increased in these individual tables, the joins were becoming very costly and long running. In order to avoid that, what we did was we created a materialized view instead of the join. And the reason for creating materialized view was because any data that was incrementally that was changed in the base table was incrementally written to the materialized view without much user intervention. And in case the base table changed and invalidated the materialized view, then the queries were directly routed to the base table. And so BigQuery does offer some performance enhancements on using materialized view in case of such type of queries. In terms of alerting, what we use is basically the out-of-the-box alert system that GCP provides in case of Cloud Run, Dataflow, PubSub. We can configure alerts as per our use case. We also have an in-house metric collection service which collects the metrics of data at each stage. We basically write all the metadata related to the data stages in a KV store and as an append-only log, and our analytics service reads that to give real-time metrics on the data. Through this, we have also enhanced error reporting and can easily get insights on data quality of the ingested data. So what we basically achieved by using this new architecture on similar type of data was we observed a cost reduction of around 30%. This can be attributed to the on-demand provisioning of assets. So, for example, if a org does not require the batch processing of data, then we do not provision the entire batch infrastructure for the processing. And earlier, all the cloud assets were at a data source level to avoid blocking of one source from another. But now we have moved it to the at an org level. So any cloud assets that are provisioned are at a project level, and all the data sources use the same cloud infra for one project. So in that way, we have seen some cost optimization. Other than
when you move towards stream based, when you reduce the cost.
That is not the only reason for cost reduction.
Right. You want to take it? I'll take it. All right. So cost reduction in terms of, so one thing was, so failures, in terms of failures, so what will happen is we used to reprocess the entire file. So that was one part where the cost reduction was decreased, because now since it was event processing instead of a batch processing, we had to just reprocess the number of events which had failed. Second thing was in terms of CDF, we had done a calculation of the cost in terms of the hours in which the CDF ran, the data per cluster ran for a long while. Internally, it might not be even doing anything. It could be that one stage is stuck, or there's been a lot of values for a particular key on which the data frame is partitioned. Internally, it's not doing anything, but it's still stuck. The cost is still running. Whereas since now again it's an event based, I understand where you're coming from.
Normally, the way I see,
yes,
it's vice versa, but it might be you guys have some different way where you save the cost. Another thing is because your services will keep on running all the time, right? To get the data, and there will be always streams ingesting data to the server, right?
Yeah. So
now you have to deal with, I think always live is quite challenging in terms of securing those services. You expose the endpoint that's giving services endpoint directly, or you have some other service on top of that?
So we have divided our architecture into a control plane and data plane. Data plane is not exposed to the end user directly. It's only via the control plane that the user can interact with the data plane.
Right. So again, in that scenario, authenticating, authorizing always for each and every request, it's quite heavy. It's quite low, quite a lot low to the service. Here I was able to batch at the time, and I was able to do 6.4. The smaller messages has to go from different clients, and another division authorization need to happen for each and every request. So how do you guys think of that?
So I didn't get your point about the services of the authorization part. For each event, this is what exactly was that point that I did not.
For example, there are thousands or millions of clients,
right?
And earlier, if you are able to ingest in a batch way, for example, for 1 hour or 1 day data, you are able to ingest in one code. There, one time authentication authorization. So always your data has to go to the server, and each request has to authenticate and authorize. And you have already built some services to take care, right? All those smaller messages. So in that scenarios, there will be a lot of load to the server. How did you guys thought through or handled, or have you encountered that kind of scenario?
Yeah, just to simplify his question, like, okay, you do it to the batch processing and then you simplify the processing. Did it add extra services, extra load, extra thing which is actually running, and overall cost reduced or it increased?
So this. Nice one. So earlier also we used to get a stream of events from the downstream services, but earlier we used to batch it. So the authentication authorization part was.
You want to?
Okay. So sorry. So just to clarify the question is how do we manage authentication at scale, right, for each of the event which is coming in? So one of the fact that we have to realize is, for example, let's say I'll give an example. Let's say Flipkart.com, Amazon.com. Are two sources which are sending us the stream of data, right? So we obviously cannot validate for each and every event which is coming in. But these clients being authenticated sources, right? Whenever they create metadata around these data sets in our main platform, we offer them something called as an integration key, right? So this integration key is the first validator that they have to integrate in their individual sources. And this integration key comes as part of your event itself. Now, when this event reaches your event collector service, one of the things we have done there is we have made our authorization local, authentication and authorization local. That basically means the event collector service has a cache of all the valid integration keys. That basically means it can actively check whatever event is coming in, if the key is valid or not. If the event or the incoming stream of data is not known, that means the integration key is not valid, the event collector service drops the event there itself. So basically the core there is localizing the authorization.
to the event collector service itself. And then after every hour, it basically pulls the new authorization information, all the new sources or all the new metadata that has been created in the core platform, and that's how the authorization works currently. Yeah.
So in that case, instead of having different service to authenticate or authorize,
yes,
you have localized in a collector service itself.
Exactly.
Keys you have already
Yes.
made and
Yeah, the creation of these keys actually happens through a main proper authentication. So the clients or the marketing team of those clients, let's say I'm just taking Flipkart and Amazon as an example, the marketing team of those clients will basically come to the core platform, create their sources through a properly authenticated mechanism, and the keys will only be exposed to those teams. So there is no way that apart from our ZeoTap or anyone else who's authorized to access those keys can have access to that. And if they don't have access to the keys, the incoming event stream cannot be integrated with the keys, right? And that's how the local authentication works on that. Yeah.
Going forward, so as we mentioned, reduce processing, reduce failures, and reduce scans of data, because everything is loaded incrementally, and we just have to read the new partitions instead of reading the entire data that was earlier loaded by overwrites. So this also helped us in reducing the SLAs in terms of time taken for ingestion, because we have done it incrementally, and the ETL with micro batching. And we also have a nothing shared architecture, and everything, every transactional database or every component is replaceable with if you want to replace anything. Performance.
Just an add-on. So replaceable by here, we mean the data stores which we have right now. That is, one is Scylla and the other is BigQuery. As and when the need is required, it is a sort of a plug and play. We can, because we interact with a wrapper on top of these, so we can replace it with, let's say, another columnar storage which we feel would eventually give us better performance. So that way, this is a benefit for this particular pipeline.
And you made it correctly. Columnar we goes mostly for reading purposes. You guys have used for ingestion scenarios. But,
yes.
I mean, not mandatorily. For example, if I take an example of Scylla, it is write optimization. In fact, in read document, it is actually write documents. So it's not necessarily that every columnar database is always going to be read heavy. It can be, I mean, it depends on the case that, for example, if you have any system, like for example, if you can take example of Druid, right? It will be mostly read heavy because it is made for that kind of stuff, but Scylla is not. So it's not mandatory that every columnar database will always be reading.
Same like Cassandra.
Same like this. So Scylla is actually a drop-in replacement of Cassandra. They have made some kind of optimization on top of it, where a lot of the way that Cassandra works is basically it's a KB store, right? They have made some optimization by making it. It basically means that if a client is looking for a particular key, the driver at the client side itself knows where to look for it on which particular, and it doesn't have to go through a common node, right? Which basically then redirects the query internally to other nodes and then collect the data. So that way it avoids an internal extra hop that gives it a better management.
Yeah, cool.
All right, thank you. This is what our learnings was from this project, and we would like to take any questions. All right, thank you.
Thanks a lot, folks. Yeah, thanks a lot for coming in. We came to an end to the session. Thanks for holding up for the whole day. This means a lot. If you have any feedback, any other questions, or if you want to, do future talk proposals and other stuff, please drop a note on that event thing. I'll also share a mail ID where you can post some questions and things like that. We'll also upload the PowerPoint presentations and recordings. Cool. Thank you all. Yeah. Cool.